The Langwa Group acquired the pioneering Ceylon Steel Corporation in 2009, revamping and relaunching with Langwa Sanstha Vane as its key brand, manufacturing a range of industry benchmarked QT bars, box bars and round bars in a variety of configurations to suit market requirements and needs. Sought after and the choice of professionals across the island, Langwa Sanstha Vane is today the undisputed leader in the manufacture of steel products in Sri Lanka. Going beyond the mere production of cement and with the goal of maintaining the highest standards and specifications for quality raw materials and production processes, Langwa Sanstha Cement Corporation Private Limited opened the largest production facility of its kind in Sri Lanka in March 2022, marking a new dawn for the construction industry in Sri Lanka. State-of-the-art production facility located in the export processing zone Mirijjavila, Hambantota incorporates a 2.4-kilometer conveyor system that links the Hambantota port to the factory, minimizing the impact to the environment. Only state-of-the-art facility of its kind in Sri Lanka is monitored by a fully automated control room to deliver cement products of the highest quality to the construction industry. The brand produces a wide range of cement products including Portland composite cement, ordinary Portland cement, and blended hydraulic cement. Is distributed throughout the island using the largest distribution network in Sri Lanka. Langwa Sanstha Cement Corporation Private Limited has also ventured into producing an innovation range under the Langwa Supergrades name that includes SLS certified tile adhesive Standard Fix C1 and Ultrafix C2 tile mortar, as well as skim coat interior and skim coat exterior to meet market demand. Langwa Sanstha Cement Corporation Private Limited has, in a very short time, achieved the distinction of delivering comprehensive cement solutions for large-scale commercial and industrial projects, having established a legacy of quality and winning the trust of Sri Lankans over many decades with Ceylon Steel. Langwa Sanstha Cement and Langwa Supergrades together are undoubtedly the foundation of construction raw materials in Sri Lanka. Langwa, a trusted bond.
In the life cycle of any construction, challenges are inevitable. From the insidious spread of corrosion and the silent threat of structural cracks, to the devastating impact of fire and the persistent damage caused by water. These issues threaten lives, devalue assets, and erode investments. At Aero Solutions, we provide the advanced protection solutions that address these very challenges head-on. With over 15 years of industry leadership in the construction and industrial sectors of Sri Lanka, we are dedicated to safeguarding your assets and ensuring peace of mind. We achieve this by partnering with world-renowned brands like Nullifier, RD Coatings, Firespray, VIP Coatings, and Excalibur, bringing you the highest quality products and unparalleled expertise. Our commitment is to deliver smart protection that meets the most stringent international standards for every project. Corrosion protection with RD Coating. For superior corrosion protection, Aero Solutions proudly partners with RD Coatings, a trusted brand in water-based technology. We are the sole distributor and approved applicator for RD Coatings products in Sri Lanka. RD Coatings offers cutting-edge solutions for various environments. RD Monoguard, a next-generation water-based anti-corrosion coating that provides long-term protection, high UV resistance, fast drying, and surface tolerance. It's a single-component solution capable of protecting steel for over 15 years in C5 marine or industrial environments. RD Elastometal, a high-performance elastomeric coating with superior anti-corrosion and waterproofing properties. It adheres perfectly to various substrates, offering high elasticity and durability, even in the most severe weather conditions. RD coating systems are designed for minimum 15-year durability, tailored for C3, C4, and C5 environments, ensuring long-lasting protection for your steel assets. Passive and structural fire protection with Nullifier. At the heart of our fire safety solutions are passive fire protection and structural fire protection, a critical element in compartmentation and preventing the spread of fire. We are the sole distributor and approved applicator for Nullifier UK products in Sri Lanka, a globally recognized leader in intumescent fireproofing and fire stops. For sealing joints, gaps, and service penetrations, we utilize FS 702 waterborne intumescent acrylic sealant, FS 709 intumescent mastic, and FF 197 fire-rated PU construction foam, all designed for superior fire resistance and sealing. To seal combustible pipes passing through walls and floors, we offer FP 170 intumescent pipe collars and FP 300 intumescent pipe wrap, providing robust fire-stopping capabilities for up to 240 minutes. Our intumescent coatings are meticulously selected based on ISO 12944 and ETAG standards, ensuring optimal performance across various corrosive environments. FB 750 coated batt, a mineral fiber board with an ablative elastomeric coating, offering up to 240 minutes of fire resistance for various penetrations. For structural steel, we offer advanced intumescent coatings like SC 801, SC 902, and SC 601. These thin film coatings expand in a fire to provide insulation, protecting steel structures for up to 120 minutes. SC 902 in particular is a fast-track on-site, low VOC solution. Duct fireproofing with Firespray. Ensuring safety and ventilation systems is paramount, and for duct fireproofing, Aero Solutions collaborates with Firespray Flamebar UK, experts in passive fire protection systems for ductwork. Firespray solutions include Flamebar BW11, a specially formulated water-based ablative coating that provides enhanced performance in fire-rated ductwork systems, contributing to containment of ventilation smoke, pressurization, and kitchen extract ductwork. Flamebar intumescent acrylic sealant, a key component for fire-rated ductwork systems, sealing joints and penetrations, offering 4-hour integrity and insulation rating. Flamebar fire retardant gasket, a highly flexible PVC nitrile rubber foam tape designed to be squeezed between duct flanges, ensuring a high-quality seal and preventing the ingress of grease while providing a crucial fire barrier. These systems are manufactured and supplied worldwide, meeting stringent fire safety regulations. Beyond fire protection and corrosion control, Aero Solutions extends its expertise through partnerships with VIP Coatings for polyurea and polyaspartic coating technologies for waterproofing, roofing, and industrial flooring, and Excalibur USA for construction chemical products, including waterproofing, concrete repair, grouts, and expansion joint systems. These strategic alliances allow us to offer a diverse range of high-performance solutions for various construction needs. We are committed to excellence in every endeavor. For smart protection and a safer future, contact Aero Solutions today.
Tomorrow, how will we inhabit our cities when 70% of us live in them? Faced with the challenges of a changing planet, will they be resilient? The answer lies in the materials that shape our world. The buildings we live and work in, the bridges we cross, the tunnels we pass through, and the roads we travel, all need to be built to withstand the complexities of our times. At CRISO, we partner with you to turn complex challenges into compelling answers. We unlock the power of chemistry to develop the future of cement and concrete materials, aligning with your priorities of decarbonization and efficiency. Driving new levers of performance with chemical solutions tailor-made for your specific needs, inventing them if necessary. In a world of declining resources and rising transport costs, we foster the circular economy and help you transform local materials into added value. As cities grow vertically and your projects take on new dimensions, we enable you to build without limits. We explore the limitless possibilities of digital technology and AI through the entire value chain, working alongside you to push the boundaries of construction. We build bridges between your projects, our innovation, and our talented teams. Together, we're crafting a new world. A world where challenges become solutions, and complexity is transformed into opportunity. CRISO, pioneering the future of construction now.
We are Marga Engineering, Sri Lanka's largest and most trusted construction company. And our story is one of ingenuity, excellence, and resolve. Over the last 3 decades, our footprint has etched across more than 500 multidisciplinary projects. 35 years ago, Mr. M.G. Kularatna founded Marga Engineering with a vision to become a model construction company in the region. Spurred by its vibrant and talented nucleus, Marga seized the opportunities to work alongside some of the world's leading construction companies, instilling within a quality-centered focus that became its trademark. From inception, we have strived to embed the ethos of sustainable development across the organization. We are the first privately owned company in Sri Lanka to publish under the Global Reporting Initiative. The trust we have earned from our stakeholders have manifested through our platinum rating in Sri Lanka's Corporate Accountability Index and our environmental stewardship through the first Green Award in the public and private sector. As Asia becomes the fastest growing region in global construction and our breadth of experience and talent opens new opportunities around us, our vision has remained as unwavering as ever: to build lasting social infrastructure and to change the landscapes around us for the better. Marga, changing landscapes, changing lives.
Welcome to the terrace apartments of Emerita Kelaniya, the very first exclusive boutique apartment in Sri Lanka. It's like living in a forest canopy, elevated above the city. Here, nature isn't just outside your window, a living, breathing connection to nature, from your bedroom to your living room. Your own private sky garden, with fully grown trees hand-picked by you. A living experience like dwelling in a mountain cave wrapped with trees. Step inside. Every apartment is fully furnished, designed with style and intention. Each room opens to a private balcony garden, blending indoors and outdoors. The bathrooms? Spacious, spa-inspired. Everything thoughtfully chosen to feel calm, clean, and elevated. At Emerita, every detail is curated for a life like living in a boutique hotel. Enjoy an unlimited all-day buffet by the Fab. Come home to a spotless apartment, cleaned daily by Abans Environmental Services. A wellness zone, steam room, sauna, gym, hot and cold therapy pool, and a tree-lined jogging path. A clubhouse, a restored Art Deco mansion, offers a gaming arena, mini cinema, and a curated library. A world-class lifestyle delivered through our strategic partners, Abans Environmental Services, the Fab, and Hammers Hospitals. Just 16 minutes to Goalface when the port access elevated highway opens. And only 35 uniquely designed homes. Only a few terrace apartments remain. This is your moment. Emerita Kelaniya, the design of life you live.
Across our cities, development is reshaping skylines and redefining what's possible. Every day, new structures rise more ambitious, more complex, and more essential to the growth of our economy. From landmark commercial spaces to vital infrastructure, construction is a symbol of resilience and progress. In the world of construction, every project involves risk. At any stage, unexpected challenges can impact people, property, timelines, and investment. Natural disasters, accidents, and liabilities can disrupt progress and put entire projects on hold. That's why having the right insurance partner matters. A team that understands the complexity of your industry, who can assess risks across every phase, and create solutions designed to protect your ambitions and safeguard your investment. As your insurance partner, we create customized insurance programs tailored for construction businesses, aiming to protect both material damage and liability risks. Whether it's navigating complex construction all-risk requirements or designing a liability insurance program, we have the ability to put a custom program in place to manage the unique requirements of your business. When working with you, we ask the right questions, go through standardized checklists, and get a full understanding of your construction business. We help you manage risks before issues arise, and when you do happen to have an insurance claim, our full-time claims professionals ensure they are handled quickly, efficiently, and correctly on your behalf. We are true advocates for our clients, and we have strong relationship with the insurance companies to manage your claims and represent your needs in the best way possible.
At IIRM, our mission is simple: to protect your people, to protect your properties, and protect your investment. We serve over 1,000 customers per year, and we place 11,000 corporate policies. We manage 3,000 claims per annum. We have a team of over 40 qualified staff who brings expertise in insurance, including property, engineering, marine, liability, and employee protection. Behind every structure, there is a vision. Every vision needs protection. We are here to help you from groundbreaking to project handover, whether it's simple or complex.
IRM Lanka is a subsidiary of IRM Holdings, Singapore, having associate companies in India, Maldives, and Kenya. In today's global business landscape, IRM delivers smarter insurance solutions backed by strong international reinsurance partnership with markets in Dubai, Singapore, India, Africa, and in USA.
Wherever you build, whatever you envision, we are here for you. We will take care of you. IIRM, your partner in protection, representation, and peace of mind.
IIRM, your trusted insurance partner. Call us on 011-7589-601 or 0763-772-321. Visit us at iirm.lk.
The Langwa Group acquired the pioneering Ceylon Steel Corporation in 2009, revamping and relaunching with Langwa Sanstha Vani as its key brand, manufacturing a range of industry benchmarked QT bars, box bars and round bars in a variety of configurations to suit market requirements and needs. Sought after and the choice of professionals across the island, Langwa Sanstha Vani is today the undisputed leader in the manufacture of steel products in Sri Lanka. Going beyond the mere production of cement and with the goal of maintaining the highest standards and specifications for quality raw materials and production processes, Langwa Sanstha Cement Corporation Private Limited opened the largest production facility of its kind in Sri Lanka in March 2022, marking a new dawn for the construction industry in Sri Lanka. State-of-the-art production facility located in the Export Processing Zone, Mirijavila, Hambantota, incorporates a 2.4-kilometer conveyor system that links the Hambantota port to the factory, minimizing the impact to the environment. Only state-of-the-art facility of its kind in Sri Lanka is monitored by a fully automated control room to deliver cement products of the highest quality to the construction industry. The brand produces a wide range of cement products including Portland composite cement, ordinary Portland cement, and blended hydraulic cement. Is distributed throughout the island using the largest distribution network in Sri Lanka. Langwa Sanstha Cement Corporation Private Limited has also ventured into producing an innovation range under the Langwa Supergrades name that includes SLS certified tile adhesive Standard Fix C1 and Ultrafix C2 tile mortar, as well as skim coat interior and skim coat exterior to meet market demand. Langwa Sanstha Cement Corporation Private Limited has, in a very short time, achieved the distinction of delivering comprehensive cement solutions for large-scale commercial and industrial projects, having established a legacy of quality and winning the trust of Sri Lankans over many decades with Ceylon Steel. Langwa Sanstha Cement and Langwa Supergrades together are undoubtedly the foundation of construction raw materials in Sri Lanka. Langwa, a trusted bond.
In the life cycle of any construction, challenges are inevitable. From the insidious spread of corrosion and the silent threat of structural cracks, to the devastating impact of fire and the persistent damage caused by water, these issues threaten lives, devalue assets, and erode investments. At Aero Solutions, we provide the advanced protection solutions that address these very challenges head-on. With over 15 years of industry leadership in the construction and industrial sectors of Sri Lanka, we are dedicated to safeguarding your assets and ensuring peace of mind. We achieve this by partnering with world-renowned brands like Nullifier, RD Coatings, Firespray, VIP Coatings, and Excalibur, bringing you the highest quality products and unparalleled expertise. Our commitment is to deliver smart protection that meets the most stringent international standards for every project. Corrosion protection with RD Coating. For superior corrosion protection, Aero Solutions proudly partners with RD Coatings, a trusted brand in water-based technology. We are the sole distributor and approved applicator for RD Coatings products in Sri Lanka. RD Coatings offers cutting-edge solutions for various environments. RD Monoguard, a next-generation water-based anti-corrosion coating that provides long-term protection, high UV resistance, fast drying, and surface tolerance. It's a single-component solution capable of protecting steel for over 15 years in C5 marine or industrial environments. RD Elastometal, a high-performance elastomeric coating with superior anti-corrosion and waterproofing properties. It adheres perfectly to various substrates, offering high elasticity and durability, even in the most severe weather conditions. RD coating systems are designed for minimum 15-year durability, tailored for C3, C4, and C5 environments, ensuring long-lasting protection for your steel assets. Passive and structural fire protection with Nullifier. At the heart of our fire safety solutions are passive fire protection and structural fire protection, a critical element in compartmentation and preventing the spread of fire. We are the sole distributor and approved applicator for Nullifier UK products in Sri Lanka, a globally recognized leader in intumescent fireproofing and fire stops. For sealing joints, gaps, and service penetrations, we utilize FS 702 waterborne intumescent acrylic sealant, FS 709 intumescent mastic, and FF 197 fire-rated PU construction foam, all designed for superior fire resistance and sealing. To seal combustible pipes passing through walls and floors, we offer FP 170 intumescent pipe collars and FP 300 intumescent pipe wrap, providing robust fire-stopping capabilities for up to 240 minutes. Our intumescent coatings are meticulously selected based on ISO 12944 and ETAG standards, ensuring optimal performance across various corrosive environments. FB 750 coated batt, a mineral fiber board with an ablative elastomeric coating, offering up to 240 minutes of fire resistance for various penetrations. For structural steel, we offer advanced intumescent coatings like SC 801, SC 902, and SC 601. These thin film coatings expand in a fire to provide insulation, protecting steel structures for up to 120 minutes. SC 902 in particular is a fast-track on-site, low VOC solution. Duct fireproofing with Firespray. Ensuring safety and ventilation systems is paramount, and for duct fireproofing, Aero Solutions collaborates with Firespray Flamebar UK, experts in passive fire protection systems for ductwork. Firespray solutions include Flamebar BW11, a specially formulated water-based ablative coating that provides enhanced performance in fire-rated ductwork systems, contributing to containment of ventilation smoke, pressurization, and kitchen extract ductwork. Flamebar intumescent acrylic sealant, a key component for fire-rated ductwork systems, sealing joints and penetrations, offering 4-hour integrity and insulation rating. Flamebar fire retardant gasket, a highly flexible PVC nitrile rubber foam tape designed to be squeezed between duct flanges, ensuring a high-quality seal and preventing the ingress of grease while providing a crucial fire barrier. These systems are manufactured and supplied worldwide, meeting stringent fire safety regulations. Beyond fire protection and corrosion control, Aero Solutions extends its expertise through partnerships with VIP coatings for polyurea and polyaspartic coating technologies for waterproofing, roofing, and industrial flooring, and Excalibur USA for construction chemical products, including waterproofing, concrete repair, grouts, and expansion joint systems. These strategic alliances allow us to offer a diverse range of high-performance solutions for various construction needs. We are committed to excellence in every endeavor. For smart protection and a safer future, contact Aero Solutions today.
Tomorrow, how will we inhabit our cities when 70% of us live in them? Faced with the challenges of a changing planet, will they be resilient? The answer lies in the materials that shape our world. The buildings we live and work in, the bridges we cross, the tunnels we pass through, and the roads we travel, all need to be built to withstand the complexities of our times. At CRISO, we partner with you to turn complex challenges into compelling answers. We unlock the power of chemistry to develop the future of cement and concrete materials, aligning with your priorities of decarbonization and efficiency. Driving new levers of performance with chemical solutions tailor-made for your specific needs, inventing them if necessary. In a world of declining resources and rising transport costs, we foster the circular economy and help you transform local materials into added value. As cities grow vertically and your projects take on new dimensions, we enable you to build without limits. We explore the limitless possibilities of digital technology and AI through the entire value chain, working alongside you to push the boundaries of construction. We build bridges between your projects, our innovation, and our talented teams. Together, we're crafting a new world. A world where challenges become solutions, and complexity is transformed into opportunity. CRISO, pioneering the future of construction now.
Ladies and gentlemen, distinguished guests, a very good evening to you all. On behalf of the Council on Tall Buildings and Urban Habitat, it is my great honor to welcome you to the CTBUH Colombo Forum 2025. This year's theme, Vertical Vision, celebrates the spirit of innovation, sustainability, and excellence in high-rise development. We are thrilled to host some of the most influential voices in the construction, design, and urban development of Sri Lanka. We begin this evening with a significant tradition, lighting of the oil lamp, followed by the national anthem. May I now invite our distinguished guest for the ceremonial virtual lighting. Please use the pointer to light the oil lamp. Mr. Ravi Nissanka, Chairman of the Industrial Development Board of Ceylon. Engineer Granny R. Jayalat, President, the Institution of Engineers, Sri Lanka. Architect Dilmini Demel, President, Sri Lanka Institute of Architects. Professor Emeritus Ranjit Disanayaka, Immediate Past President, the Institution of Engineers, Sri Lanka. Architect Jayantha Pereira, President of Green Building Council of Sri Lanka. Engineer KLS Sahabandhu, President of Sri Lanka Geotechnical Society. Engineer R.M. Ananda Senarath, President of Society of Structural Engineers, Sri Lanka. Mr. Indika Geekiyanage, General Manager of Langwa Sanstha Cement Corporation. Chartered Quantity Surveyor Indranil Senaviratna, President, Institute of Quantity Surveyors, Sri Lanka. Dr. Rohan Karunaratna, President, Ceylon Institute of Builders. Engineer T.J. Jayasundara, immediate past President of Society of Structural Engineers, Sri Lanka. Mr. Adrian Panyakolo, Dr. Pasindu Veerasinghe, keynote speakers of the evening. Engineer Shiromal Fernando, country representative of CTBUH Sri Lanka. Architect Nirodha Gunadasa, Vice President of CTBUH Sri Lanka. Dr. Tushara Priyadarshana, member CTBUH Sri Lanka. Mr. Ruwan Padaruheva, Treasurer CTBUH Sri Lanka. And Engineer Yasas Gunawardana, member CTBUH Sri Lanka. Please stand for the national anthem. Before we dive into today's session, let's take a moment to set the stage. Ladies and gentlemen, presenting our conference introduction video. Let the air be filled with applause as we welcome Engineer Shiromal Fernando, the Deputy Chairman, Principal Structural Engineer of CSEC and Country Representative of CTBUH Sri Lanka, for his heartwarming welcome address. His words will undoubtedly set the tone for an evening filled with inspiration. Mr. Shiromal.
Good evening, everyone. The total industry is here because Council of Tall Building is not only about engineering or architecture, it's all about the total building sector, including the entrepreneurs, the developers, the manufacturers, innovators, researchers get together. So this is why we see all the presidents of the country from different institutions are here, and we are we welcome all of them for this August gathering. So initially, I like to welcome our chief guest, Mr. Ravi Nishankar, Chairman, Industry Development Board of Ceylon. He was part of the industry. It's a honor for us to have him with his busy schedule here. And also the keynote speakers, Mr. Adrian, Senior Design Manager from Spark North East Link Project Australia, Professor Priyan Mendis, University of Melbourne, Australia, and Dr. Pasindo Veerasinghe, Senior Lecturer, Department of Civil Engineering, University of Moratuwa. So, tall building, CTBUH is the apex body that decides the tallest building in the world. So, we are proud to. It's one of the most prestigious institution in the tall building industry. So we have more than 2 million members, including 10,000 officers in more than 100 countries. So we all invite you all to join the council, and we have a new member, Mr. Vajiratnayaka, joining this time. We are happy to welcome him. We have many publications addressing these, addressing the very needed issues that has to be addressed on tall buildings, where no national or international guidelines are available. So basically, there are awards for the best practices and also the individuals who contribute to the industry. Last year before, actually, Lotus Tower was recognized as one of the best tall buildings in the world. It was a great honor to be part of that team, and Professor Mendes and most of the team members were there to receive the award. So we have conferences all over the world, and this time the main conference is in Toronto, Canada, in October, 6th to 9th. So if you are interested in meeting the top tall building designers, urban designers, architects, we welcome you to join that gathering. So, today's chief guest, Ravi Nishankar, we thank you again for attending our conference, and I think I have the first international conference. I went with him to Shanghai in maybe 10-15 years ago. So thank you for continuing the support. He has been a tremendous strength to our council before even became the industry leader in the government. We also welcome our honored guests who are all presidents from many institutions, engineers institution, Mr. Jayalat, then architect Jayanta Pereira, the CCI president, and also Rohan Karunaratne from Institute of Builders, architect Dulmini De Silva Dimel from Architectural Institution, and Mr. Charad QS Indunil, Mr. Senarat, although he is not here, Tarangika is representing the Society of Structural Engineers, and Mr. Kele Samad told me that he won't be able to come today. We are also thank him for his support, and Professor Ranjit always is with us on all the occasions, and we are honored to have you all. So we discuss about, today is a very interesting topic that we are discussing on vertical vision. Professor Mendes will be talking about materials and his knowledge about, disseminate his knowledge about the modern construction methods. Mr. Adrian will be talking about the key aspects of tall buildings. His main topic is about going vertical, opportunities and challenges. So he's the best person. He came to Sri Lanka within a short notice. It's an honor to have you, Mr. Adrian, and hope the crowd will enjoy your. Dr. Veer Singh is an expert on fire. Fire is a key aspect of tall building resilience. So you will enjoy his talk during the day. So basically, with respect to the cities, people migrate to the cities for different reasons. Generally, in most of the developed world, 80% of the people live in cities. So in Asian countries is around 30 to 35%. The trend is the city land prices are exceeding, and the trend is to build vertical. There's no other option to build vertical to get the ROI. And during the last couple of years, thousands of tall buildings above 40 floors are being built in the world, especially in Asia. So when you build, this is going to happen. So this is Beijing, one of the most developed cities in the world. This is Mumbai. the most developed city in India. You know, the Ambanis are living there, Tendulkars are living there. You know, the Mumbai Indians, most of the richest. This is Brazil. So if you do not think about how we are going to develop our city, then there is a issue. The people are sick in these cities. They may be rich in numbers, but people are sick in these cities. This is Delhi. So, see Colombo, one of the most beautiful cities in the world. So, according to our estimate, there will be about 170% increase in the population in our city. So basically, it's very, the land availability in the city is very low, and it is considered as the fastest growing city in the world. You can see in 1990s our cityscape, and now it is completely different. And the port city will also give rise to many buildings. This is what we have done for the shanty dwellers, how we address. So is that the way we are going to go? There is nothing green. So we will also end up like a Brazil or a Mumbai or this thing in the name of development. We have polycentric cities where people come from far away to the city to work. This is how we travel. So very important that we have monocentric cities where within 1 kilometer we should be able to get to our office, the workplace, the play areas, etc., etc., and our groceries, the offices, and our dwellings. Resilience is a very important thing in a city. Due to the wind, we should make sure that our cities are resilient. Due to the earthquake, our cities should be resilient. Due to the fire is a major hazard that most of the tall cities are being. We have to be resilient. We have to be resilient against. This is Colombo. Fire chief also in the audience. So it's very important that we look at this. And we also have to look at the external threats, man-made threats due to prejudice. So our cities should be resilient against these aspects. This is the city that we want. So let's put that in mind, and all the stakeholders in the industry are here. Let's work together to build our dream city. Thank you.
Thank you, Mr. Sharma. Let us warmly welcome architect Nirodha Gunadasa, the Vice President of CTBUH, Sri Lanka, to the stage. His opening remarks promise to provide us with valuable insights and perspectives that will guide us on this intellectual journey.
Right, okay. Is this thing working, isn't it? I need this thing, yeah. Right, okay, so my duty is to give the introduction to the theme this time. So let me begin with a question that terrifies CTBUH. Why do you need these tall buildings? Why do you need them? Can't we all live like this, all of us? What do you think? To the horror of our CTBUH chairman, the answer is yes. Yes, we all can live like that. We don't need all those tall buildings, but that is 100 years ago, not now. Today, if you think about it, there's no way to do it. But what's the difference? Actually, 100 years ago, majority of the world population lived like that. So why can't we do it today? So this is the place we live, our planet. And 100 years ago, we had 2 billion people living here. Just the right number of people fitting to this particular planet. And it's like having a 2-bedroom house and having 2 people to live. Each one can have a single bedroom. But what happened today? Today we have 8 billion people living in this world. And it is estimated by 2100 there will be 11 billion people. So when you have a 2-bedroom house and you have 11 people to live inside that, you have to change your strategy of living. Right, so if 11 billion people start to live like this, can you hear me clearly? Yeah, if 11 billion people start to live like this on this planet, it will take up massive amount of natural land and massive infrastructure networks are required. And there will be a climate crisis just because of that. Okay, so the good thing is, as Mr. Shuramal also pointed out, the mega cities of the world are at a tremendous growth today. Should I point here or there? Ah, yes. Okay. So these are some of the mega cities. So he showed what's happening in Colombo, but if you look at even New Delhi, from 2011 to 2024, there has been 43% growth in New Delhi, and there has been 53% growth in Dhaka, and we have Beijing 44%. Even the developed countries like New York, we have 20% growth. So mega cities are at tremendous growth, and billions of people are today moving into cities. It's a good thing, because knowing or unknowing, by doing so, these people are contributing to make our world a more sustainable place. So this is the world urban population. By 1980s, we had 1 billion people living in cities. And 2015, or right now, we have more than 3 billion people living in the cities. And it is estimated by 2050, we will have 6 billion people. Look at the numbers, 3 billion now, 6 billion in just 25 years. So by 2050, we need cities for 3 billion more people. Right now, we only have 3 billion, and we need cities for 3 billion more people. So it's just doubling the global urban population. And few people understand that this is the biggest force working on Earth today, the biggest force. All these bright dots in the world is a city. And they are going to be double in size and grow twice in just 25 years. So it's the biggest movement on Earth, and as professionals, we have to make sure that we do it in a sustainable way. We direct these people, settlements and all, in a sustainable way. Unless we do that, there's a problem. So we need cities for 3 billion people, and we have to get it right. So unless we get it right, so if we are not going to get it right, all these climate solutions we are talking about, we have the green building chairman here, all those solutions we are talking about are not going to save the planet. So this is the most important thing. Right, so we need sustainable urban planning. And we cannot think about cities two-dimensionally as earlier we thought, just plans. We have to have three-dimensional plans for cities. We have to use the vertical axis, and we have to go tall. There's no other option. So that's why we need tall buildings today. So he's not happy. Okay, but the second question is, okay, we can go high, but how tall can we build? How tall can we build? What is the maximum limit? This is a 10-meter tall building. It's 10 meter by 10 meter cube. So if I make this 10 kilometer by 10 kilometer by 10 kilometer by cube, I think everybody agrees with me, in this small cube, 3 people can live happily. It's a big cube. So if we scale it up like that, I think we can house all these 3 billion people we are talking about. So it's big enough to do that. But can we do this? can we build this kind of a cube? Is it possible? It cannot be done. Why? It cannot be done due to a very, very fundamental basic reason. I'll explain what it is. So this is a simple cube. Its lengths are 1, 1, 1, 1, whatever unit, it doesn't matter. And its density is 1. So the weight of this cube, I think everybody can calculate it. It's 1 by 1 by 1, that is the volume times the density. That's the weight of this. And I'm talking about this base area of this cube, which is 1 by 1, it is 1. And I'm interested in the pressure. What is the amount of pressure that is going to be there at the base? So it's the weight divided by the base, and we get 1. What happens if I scale this up? If I make this bigger, 10 times bigger, let's say. If I make this 10 times bigger, the length 10 by 10 by 10. And if you make the same cube at the same material, its weight is going to be, I have to press this hard, isn't it? Yeah, it's 10 by 10 by 10 times 1, 1000. But the base size is only 10 by 10. So what happens? The pressure becomes 10. So you can see the same material, same structure. When you just scale it up, you get 10 times pressure on the base. So when you have this 10 meter building, when you scale up to 10 kilometer thing, what will happen? We will have 1,000 times more pressure. If this is a concrete building, these foundations are going to have 1,000 times more pressure. So what happens? These things collapse. So we can't construct such buildings. I think you have played with these glass balls when you are small. When you drop it on a cement floor, it tuck, it bounces up. What will happen if you drop this kind of a glass ball? It smashes into pieces. Why? Just because it is big. So this we can see even in nature. So when you look at an elephant like this, it has such a huge legs. And a deer doesn't need that kind of legs just because the deer is little small. And if you take an ant like this, it has this tiny little feet. So if you scale this ant to the size of an element, if you make this an elephant, this element will never be able to get up this tiny little flimsy legs. So scale matters. So even if you look at a building, it's the same thing. So 1 meter building, I think you have made models like this at the university. You can make this kind of a fancy model, but you can't do it at 100 meter height. It collapses. Right, so therefore designing tall is not easy, it's a difficult thing. Okay, so the reason is tall buildings, when we are talking about tall buildings, we are working at the threshold of collapse. That's the important thing we have to notice. And I think we have Professor Ranjit here. He's I have to go back, isn't it? He's the king of biomimicry, isn't it? So your students come to me and then say, why don't you design buildings like this, tall buildings like this? It has a lot of views, lot of social interaction, everything, if you design a building like this. Now you know why we can't build tall buildings like this. They collapse. So I like to design this kind of a building. This is a stone I have seen in Savannah. So we can't design buildings like this. It's difficult. So if I were an ant, I would have designed a tall building like this. But at this scale, it collapses. And I love to design buildings like this tall building. It will be very fantastic, but we can't design buildings like that. They collapse. So architect Ransafiano says, architects spend their entire lifetime with this unreasonable idea that you can fight against gravity. So people who know that, they don't go to do that. Right. This thing is not working well. Okay. Right, so architects can't do it. So these kind of things architect can't do. So 1,000 kilometers, this 10-kilometer building nobody can do. But we have people who can do, let's say, 1-kilometer building, because breaking this pressure barrier is possible. So for example, now today we are bringing Professor Priyan Mendis, who is an expert on that, who is a world eminent scientist who has discovered high-strength concrete to design foundations of tall buildings, and he has contributed to do many world-class buildings. So that's why I just pointed out this. So that's the physical limitation of designing buildings, the physics limitation. So clever people like Professor can handle that a little bit. But the thing is, that's not the real limitation in tall buildings. In the tall buildings, we have the efficiency limitation, or the most importantly, I call it the sustainability limitation. So what is this efficiency limitation? Something important to understand, very important, so I will go a little deep into that. So just think a tall building as a bottle like this. This bottle we have to fill. We have to fill it and also drain off. Fill with what? We can fill with people. We have to fill it with water, and we have to drain off sewer. So that's what we are doing with tall buildings. And the challenge is we have to do it in a given time called T. Because my building is very tall, I'm not going to go to the lobby and wait for, let's say, 10 minutes till the lift comes, because I understand, I respect it's a tall building. No. Everybody wants to go to their office in 2 minutes, regardless of the height of their building. So T is a constant, we can't change it. So this is the bottom area of the building. So let's say cross-sectional area, I'll call it capital A. And let me number this. First floor, second floor, third floor goes up to nth floor. These are the floors of the building. And then the volume we have to fill is A times n. It's clear for you, isn't it? This is the inlet of the building. So you put things inside that. That area I'll take as A. And the speed we pump things up, I'll take as V. So our flow rate is A times V. It's clear for everybody, I suppose. But there's a little difference in a bottle and a tall building. There's only one difference. There is a central core. So you don't fill it like a bottle. You bring things through the core and then fill in. So it is not correct to say that A times N, this is the area to fill, volume to fill. It has to be A minus this little A times N, because we are filling only the sides. So you can now calculate the time to fill the bottle. It's very easy. It's the volume to fill divided by the flow rate. It's A minus A times this thing, the top thing divided by the bottom thing. That's all. It's very simple, isn't it? Everybody can understand it. So let me keep this. Yeah, I'll take it up and keep it up there. So I have just changed the order of it. I have taken the A out. It's a simple thing I'm explaining. So I just talked about this because I want to explain you what is the efficiency of the tall building. It's something very important. So the efficiency E. Efficiency is, now if this is the bottle, the total area to the usable area ratio. Yeah, so it is the usable area divided by the gross area, and it is A minus A divided by A. So I'll just simply take that A I have calculated up there, and I'll put it here. It's not coming, right? It's there. And then we get a very simple equation like this, E equals Vt over Vt plus N. It's a very simple equation. You can work out the workings. I'm not going to do that, so you have to believe me that it is so. So what does this equation tell us? It tells us something very, very important about tall buildings. When the N increases, the efficiency goes down because they are inversely proportional. That's something simple. When you look at this, you can very simply understand. As the height of the building goes up, tall buildings become gradually inefficient, little by little. But that's not the most important thing. There are other important things you can look at when you look at this and see. Where is this A we were talking about? the cross-sectional area. It's not there. So what that means? So it regardless you are having very large land, you are building a tall building or a small land, it doesn't matter. Efficiency is efficiency. So whatever the building you build, efficiency is going to go down. It's a very drastic thing about tall buildings. And then, this is something very important, how to increase efficiency then. If you are going to do a tall building, only way is we have to work with this thing called VT, whatever it is. But you know T is a time, V is a velocity, we bring people, water kind of things up the buildings. And thing is here we have to increase it substantially because this VT is upstairs and also in the denominator. So it's not a direct relationship. So we have to increase it sufficiently and substantially, and that is something not so easy to do. So it's very difficult to increase the efficiency. So if you want to, I can calculate this VT very easily in front of you, what this VT is. Yeah. So these are the tallest buildings in the world. I think you know it. Let me keep this Burj Khalifa out of the picture for a while. And then all these buildings, they have 97 floors, 111, 93. I'll take it as 100 floors. And I know the efficiency of these buildings are about 50 to 60%. I'll take it 50, and then when you put these numbers, I get a number for VT. It is 100. It's a very simple number. And now you can use this and, for example, calculate the efficiency of a 150 floors building. If you put the numbers, you will see it's only 40% efficiency. Burj Khalifa, I left it out because its form is different. It's a cone form. Actually, its efficiency is much less than a normal tall building. A professor has worked on this. The thing is, this top part, if you calculate it, it's highly inefficient. So it's not a business sense building. It's actually a cultural pride. So just to say we have the tall building in the world, it's done like that. So in simple words, we'll just forget mathematics. This is what's happened. This is your building, and this is your competitor's building. Two buildings. The same usable area, and you save from the land. When you're doing a tall building, your competitor is using a large amount of land, and Shirom will explain that. And you are using only less amount of land. But you lose from efficiency. So that's the problem we have. And when what you lose is much more than what you gain, you lose. It's so simple. You lose in terms of business, and you lose even in terms of sustainability. So that's the failure of tall buildings we see. And although we boast CTBUH also about tall buildings, the super talls always fail. So we have Nakheel Tower, 200 floors. Professor, is it started construction? No, just on drawing board. Yeah, we have the Sky City Japan, 196 floors, just a drawing board. Just nothing has happened. And we have Jeddah Tower, they started, they did the foundation, stopped, and then they restarted, and once again, they have to stop it. We have Dubai Creek Tower, 160 floors, started, and I'm not sure that it's going on. It's stopped as far as I know. And I can show some examples in Sri Lanka as well, but I shouldn't do that. So there are a lot of projects like that. So as far as we know, the super tall always fail. The reason, I think most of the people in the world doesn't know, but now you know what the reason is. Okay, so going vertical is a challenge. So that's why I just explained this. It's a challenge, and that's why we brought an experienced person like Adrian to tell us how to face these challenges in tall buildings and also convert these challenges into opportunities. Okay, so we were talking about this efficiency limitation. Is this an unbreakable deadlock? So as human beings, can't we build more than 150 floors? Are we stuck there? How to break this barrier? I think it's possible to break it. There's a way of doing that. The problem we have is we are always thinking about having the inlet down there. That's the problem. So it need not to be there. It can be up there or even up there. So let's think this is a set of tall buildings, And this is the notion of ground. It need not to be down there at the bottom, it can be up there. And what do you mean by the ground? What I mean by ground is where I go home, where I go down to go home. It need not to be there, it can be somewhere up there. It is where I run when there's a fire. So it need not to be there. And it is where all the services come. So it can be here or there, wherever it is. So that's the concept behind this Moshe Shabdin's concept of future city. It's a very popular concept, but it never built because I think he didn't justify it so well like I did today. Otherwise it would have been built. So the idea is you have grounds at several levels. Here you have a ground level, up there you have a ground level where you go out, where you play, you have trees, you have roads, everything. So it's a multiple layer of city. So the way to go high is not individually building tall buildings, but as a city together we have to grow. So that's the way to go up. So we have even better vertical visions. For example, this Paul Bridge in 1982, he proposed this thing called the orbital ring habitat, where we have 500 kilometers away from the Earth's surface, there is a ring like that connected to Earth with space elevators like this, and people live there. It's a great vertical vision. So the idea is, I think those who know physics know it will collapse, but it doesn't fall down because it's not in the geostationary orbit, but with active means it is stabilized with this kind of fast moving trains kind of thing. Because of the centripetal acceleration, it's not falling down. The idea is everybody, we move there and we leave the Earth for animals and natural habitats. Orbital ring habitat is not just a fancy dream like the space elevator kind of thing. This is a thing practically possible. If you calculate it, it can be done. The thing is whether we have the motive to do that. So in future it might happen, I don't know. But it's a great vision. So it will be the next leap of vertical vision of humanity. But we have, I think, greater visions. So people talk about Dyson sphere, where people build a structure right surrounding the sun and capturing the entire energy output of a sun. So that is far, far away in future. It might happen. So we'll come down to Earth today. We have a problem today. We need cities for 3 billion people. And we have to get it right. And going vertical is an essential component of doing so. So that's my introduction to the theme, the vertical vision. Exploring the future of high-rise architecture. So we have several eminent speakers to talk about it. And there's no one to talk about the second part, its role in sustainable urban development. That's what I did. Okay, so that's it. So as CTBUH, we always make sure when you come here, you go home taking something that you beyond your expectation. So I think we will deliver it today. Our eminent speakers will do that. So that's it. Thank you very much.
Thank you, Mr. Nirodha. What a great introduction to the forum today. Before we move on, we would like to take a moment to extend our heartfelt appreciation to the generous sponsors who have made the CTBUH Colombo Forum 2025 possible. A special thank you to our gold sponsors, Tudave Engineering Services Private Limited, Airo Solutions, Airo Holdings Private Limited, Langwa Sanstha Cement Corporation Private Limited, and IIRM Lanka Insurance Brokers Private Limited. Your support and partnership are instrumental in shaping this platform for knowledge sharing and collaboration. We also wish to acknowledge our silver sponsors, Chriso Sen-Gobain, Maga Engineering Private Limited, Worth Lanka Private Limited, and Emerita. Thank you for standing with us and contributing to the success of this forum. It is now my honor to invite our chief guest, Mr. Ravi Nissanka, Chairman of the Industrial Development Board of Ceylon, a visionary leader and a strong advocate, to address the gathering.
Mr. Shiromal Fernando, the country representative of CTBUH, and also all the CTBUH officials, my friend Professor Priyan Mendis, the members of the academia, and also the fraternity of the industrial construction industry. I'm deeply honored and privileged to have been invited for this very important event today, because I feel, because I see all of these, most of these faces are very familiar to me, and I feel like coming home. Thank you actually for the invitation extended to me. I have been a part, and as Mr. Shiromal pointed out, I have been a part and parcel of this construction industry for the last 30 years. I have seen all the changes, the transformation from the traditionality, the modernity. I have seen it myself. I came into the industry in the early 90s, 1994. That was the year where we have been changing our construction culture. We started at that time the World Trade Center, Jai Kilton Tower, Royal Park Condominium, Central Bank Extension, Ceylan Tower. So these buildings starting from 1994. I can remember I was involved in all of these buildings. I was involved in the mixed designs, concrete mixed designs. That was the time I entered into the construction industry. My entrance to the construction industry is a sort of a very, very accidental. I saw an advertisement in the paper calling for a technical sales representative to sell concrete mixers. I went for the interview. I never realized actually, and I was selected, and I went to the job, and I realized there's no concrete mixtures for sale, but instead there were concrete admixtures for sale. I didn't know about the admixtures at that time until I went into the job. There was something called admixtures. And there was no mixture, there were no mechanical thing, all the chemicals were there. So my background was chemistry, so that I just thought it's a good chance that I need to get this capitalized. That's how I came into the industry. And at that time, I realized the industry, even concrete industry at that time was very traditional, except few places where they had only this modern mixed design culture. And 95% of the places, even the government sector, everybody was doing this wave batching at that time. So I thought it's a good industry to start with, because there's no sort of speciality with anybody. So that it was a good start, and I was joined to a company called Finco Limited. They were the agents for Master Builders Technologies. They were the pioneers who brought this construction chemical industry to Sri Lanka. And I was privileged to get their trainings in Singapore, and I was very happy, and there were a lot of technologies. We were learning about the advanced concrete technology, high-performance concrete technology, concrete repairs, the floorings, the sealants, and grouting, and all sort of things. It was quite interesting. And then I decided to make it permanent, so why not? We wanted to stick into something, and you need to challenge yourself and see what we can do in the industry. So that was my start in the construction industry, so that it's very familiar. Very coincidental that I was selected as the chairman of the Industrial Development Board. So I can do a lot of things for the construction industry. I know in and out of it. So this is a good chance, and thank you for the invitation. And look forward to work with you very closely and see all the opportunities available to bring this construction industry to the next level. Going deep into the construction industry, just to talk about a little bit about the construction industry and the growth and the potential and what we can't do and what we can do. And the previous presentation is very interesting and really thankful, and you brought up a lot of challenges to us. You said you can't do that, and there are a lot of things you can do, and there are a lot of things that you can't do. when you start thinking about the possibilities in the construction industry, we have not explored the full potential of it. I'm very much into the material area. I've been working in a lot of projects in Sri Lanka about developing sort of a materials and high-strength concrete, and I was able to sort of achieve about, I could say, in 7 days, we were able to achieve about 80 newtons, and we didn't have machines to test the 28 days results. I think you can remember I loaded up with about 100 cubes at your laboratory, and you didn't have the facility to test that after 28 days. So we could have easily achieved about, with the material that was available at that time, about 150 newtons. I believe that we can do it. But all depending on the cement that you supply, and if you downgrade the cement quality, so you know where. So you have to be very careful about the material with which you work. So I'm very happy that there are a lot of ways in which that you can develop this industry. And also now the other challenges is the time that it takes to construct. Time is money these days. There are a lot of things that you can do to make it faster. I have never seen that the construction industry is taking that leap. A lot of opportunity. You don't have to wait 7 days or just a matter of 3 days, you can achieve all that strength, nothing you're leasing. So that we don't make that advantage out of it. And also there are a lot of restrictions, and we are not following the world standards here now. A lot of restrictions, and I was a contractor also later on, and I was a road contractor. And when you go to the government sites, they don't let you lift more than 3 feet. Whereas in the world now you can go up to about 20 feet without having any consequences, no bad consequences. And also there are a lot of plus points, and you are speeding your constructions and perfect finishes, perfect consolidation, and give that a chance and try it out. And you have to break these things. And it is your thinking, and it is your need. If you don't address your thinking in an innovative way, you will be doing all the stereotype, monotonous work every day. There are a lot of things that you need to try. You come to my factory. I have put up my factory 20 feet tall walls. They're all filled up with earth. Just earth with 5% cement. And I have put that in water for 10 years, and it doesn't dissolve. So I have tested all of that. And nobody wants to try these things. 10 years in water, fully submerged in water, and it doesn't get dissolved. And all the forklifts go and hit the walls, and nothing happens. They're 9-inch walls, nothing happens. They all withstand that forces. A lot of new things that you can do. I want to tell you one example about one of the industry experience. And I was putting up my concrete batching plant, and I hired one of the chartered engineers qualified in the Sri Lankan universities. And I was road contractor at that time, and I had heaps of ABC piled up in the site. And I told him to use ABC, and use just ABC and put a little bit of cement and use that for the foundation. And he was a chartered engineer. He said, no, you can't do that. So that is the thinking of a chartered engineer, because that consists of the metal, it consists of the crusher dust, and just a matter of put some cement and put some water. I'm sure you can achieve more than 50 newtons. Easily you can use it for the foundations. I mean, that is the thinking that you need. If you are to follow all the time, if you are to follow, I mean, use your instincts. I don't expect you to do that for a 50-story building foundation, but for a simple foundation, a simple maybe 2-story house, you can still use it. And there are a lot of other material that you can use. I mean, now the engineers are looking for, I've been promoting my products in Bangladesh, and I used to travel there and see all the batching plants. And they never use all the best quality ingredients for their concrete, but they still sustain. You don't need 200 megapascal strength, the granite, all the time. There are low values that you can play with, and there are a lot of things that you can do. And getting back to my area of industries, there are a lot of developments that are taking place. The government is now coming back on track, and there are a lot of new plans off the ground, and our planning is over. for example, now the government has already allocated about 1.36 trillion capital expenditure, so that I don't think they can spend that within this year. The hope that next year is going to be a good year for the construction industry. There'll be a lot of construction will take place. So there'll be a lot of opportunities for the contractors, all the construction fraternity. So we hope, because the government tax income, the fiscal deficit has improved a lot, so that they have increased their income, nearly hitting now about 20% of the GDP, which was about less than 13%. So big income. Now the challenge that we have is in the hands of everybody is to earn more dollars. So that is where we are. So we need to make a lot of decisions. You need to take a lot of initiatives to make sure that the dollar outflow is minimized and you produce all the all the import substitutes on your own and try to export as much as you can. We are trying to propose a big project for industrial development. The main bottleneck that we have for the development of industries is that the lack of lands and readily available lands. So we are proposing to the government to allocate about 50,000 acres, as large as that, so that the land is readily available when somebody comes. So that is not for you to put up the industries in a year or two, but that is for the future. So we'll make sure that the infrastructure is available for anybody to come and invest in the country. So then it's not the duty of looking for land, the Ministry of Industries or the Industrial Development Board. So our mandate is not to look for lands and to develop the industries. So that to make sure the right infrastructure is readily available for somebody to come and start their industries. And also we are trying to start about 330 industries in each and every divisional secretariats with the help of the divisional secretariats, the members of parliament, and also the industry fraternity. And we are not trying to make sort of a competitive product to what they are selling at the moment. So what we are trying to do is to make sure the products that are being imported at the moment be manufactured. And also we take them also into the industry sector, so that all the traders who import and sell will be a part of the industrial sector, so that everybody is come to sort of a winning situation. With that, sort of, I need to I will conclude my presentation. So, and I wish you all the best, Shiromal, Professor Priyan Mendis. So everybody in the, and also all the team that is, I know there's a big team behind the stage, so that I congratulate all of you. And the way forward is very clear, so that we look forward to have more and more things from the construction industry, and wish you good luck. Thank you so much.
Thank you, Mr. Ravinisaka. Before we move on to our keynotes, we proudly present a global sponsorship video by one of our Sri Lanka's premier engineering service providers, Tudave Engineering Services Private Limited. Thank you to Dava Engineering for your invaluable support. Our first keynote speaker is a senior development professional and a strategist in high-rise projects, Mr. Adrian Paniocolo. Ms. Adrian has 35 years of experience in the construction industry, currently working on the Northeast Link project with GS&E in Melbourne as a senior design manager. His career has predominantly been on various types of projects for both engineering consulting and construction companies. His breadth of excellence extends to road, tunnel projects, hospitals, schools, industrial projects, desalination plants, and rail. His previous projects include Taiwan High-Speed Rail Project, CityLink Road Project, Eastlink Road Project, Calvary Hospital Adelaide, Melbourne Metro Tunnel Project, various level rail crossing removals, institutional facilities, and data centers. He has a Bachelor in Engineering and a Master's in Business Administration. Please welcome Mr. Adrian.
Thank you for that great introduction. Special guests and everyone here, I'm absolutely honoured to be here and to speak. We've had a few great speeches before me, and you've certainly set the benchmark pretty high in what I'll be talking about. So my talk's about the opportunities and challenges of tall buildings, and it's interesting with tall buildings. Everyone's got an opinion of a tall building, and whether it's a nice building, not so nice building, and it's something that people can see. Other types of buildings, people don't really have much of an opinion of to the same extent. So it's because it's up, it's very high profile. Okay, I'll be a lot of the start of what I'm probably talking about. There's been a bit of an overlap from what's been discussed before, but I'll just quickly touch on it. Talk about the uses of vertical buildings, challenges. Then I'll be bringing up some case studies and then talking about opportunities. Okay. And so I suppose people are constantly moving from the rural to urban areas. And there's a number of reasons, but essentially the main reasons are for employment, for health, to get access to healthcare facilities, and to go and study. There's obviously more opportunity within the city. And there's been an acceleration over the last 25 years, predominantly been in the third world countries. And as it's sort of been noted before in the previous speeches, that more than half of the world's population is actually living in urban areas. And we've got 80% of people in first world countries. It's 40 at the moment, 40% in the developing world, and rising pretty quick. So why high rise? And this has been sort of picked up before in I think the previous speeches. I think Mr. Ravi, you brought that up, and you did as well. And I suppose because of the congested area, people have to, and if people want to move, live close to the city, there's only one way, and that's to go up. And also the land is expensive, so and so, yeah, and yeah, that's the way to go. There's obviously benefits as well, that you're close to everything, and that obviously if you're in that 50-story building, you're going to have some beautiful views, which is going to be pretty nice. It's private and secure as you go up. We're living in an apartment block. So it's been around for a while. It hasn't just been in the last 50, 100 years. The Egyptians really started the process of high buildings, moved on to the Greeks, and probably in ancient Rome they perfected it even more, where typically they had 6 or 7 story buildings where they housed 40 people around that mark. And would you believe that at ground level you had shops and small businesses, and that's pretty much where things are at now. Things haven't changed too much. Even in Yemen, they had their multi-story buildings at the time, the 3rd century, around that time. And that was out of mud. And when we look at the high-rise, going higher than those figures that I just presented, it wasn't until the elevator was invented in the late 1880s that you started to get traction and buildings started to go further and further in the sky. The building that I've got there, that's I come from Melbourne, so a lot of this talk will be on Melbourne. It's called the APA building, and I think that was completed in 1890. At the same time, you had many buildings in the major cities of the world starting to rise from the ground, in particular Chicago and New York. And so this building in Melbourne, which was a 12-story building, was sort of getting close to being the tallest in the world, alongside those ones in Chicago and New York. And so what are the uses of these vertical buildings? And so the obvious ones are residential, apartments where people live, hotels, offices. There's also hospitals that are multi-storey, and now there's increasingly a lot of data centres that are cropping up, and it's going to be more so. That's going to accelerate due to the use of AI. I've also got storage facilities in big cities where you've got where people are living in small areas. They don't know what to do with a lot of things that they previously had, and they still want to keep that stuff. They just store it, and generally multi-stories is a place where they go. Well, that's what I'm actually seeing in Australia. Something that's not here, but it's interesting to note that in America, New York, they're planning a 40-story prison, and there's a 28-story prison in Chicago that was built in 1975. So it's also vertical buildings has also hit prisons. All right, so I've got them a lot of Melbourne examples here of vertical buildings, and the first is Eureka Tower. So that's a residential apartment block, which is close to 300 metres high. It's the most prestigious residential apartment block in Melbourne, if not Australia. 91 stories, 556 apartments. And when I was working as a structural consultant, I briefly worked on it. And Dr. Priyan did a lot of structural design on it and knows that building structurally intimately. And also developed, I think it was the first high strength concrete, which was 85 MPa, and now Dr. Priyan's taken that up to about, to what, 200. Yep. All right, this was a hospital that I worked on in Adelaide. 13-storey hospital in the CBD, 344 beds. And by Adelaide, well, it's actually quite small compared to a large one that was built at the time in Adelaide, which was the Royal Adelaide Hospital. This was only about a $300 million project. That came in at, I think it was 2.1 or 2.2 billion. But it wasn't as high as this. I think it was a 5 or 6 story. Now, the Queen Victoria building, that's what's called an office and mixed use building. So predominantly you've got office, you've got childcare facilities, you've got a gym, medical centre, and you've got 110 shops and restaurants within the precinct, and you've got some, and you've got a lot of car parking. Probably before I go, before I leave that slides and go back to it. Yep. I'll be talking about this building a little bit later on, how it's been pretty successful. And this is, it's actually right in the heart of the city, and it's opposite train stations. You've got trams right in front of the door, so it's easily accessed. Next use is schools that are going higher in Australia. This is a typical thing. In Melbourne, we've got 6 that are already up, and I think there's another 10 planned over the next few years. The reason why we've got these buildings is because there's more and more people living within the close to the central business district of Melbourne, but it's not well serviced with schools, and so the government's recognised this and has built these schools. The schools are actually both run by the government and also private. Yeah, then I talk about data centres, and I think we just touch base on data centres where there's been an acceleration. This is an example in Sydney, but they're occurring everywhere in Australia, and I'm sure that the same would also be happening in Sri Lanka and Colombo. It's just the world that we live in, where it's high tech. Okay, So what are the challenges? So when we talk about challenges, we start with planning, and so obviously the local government, it's their job to administer the protocols on what the requirements are if you are to build, and generally for high-rise, they are pretty strict, where it could be colours, it could be the materials that you use, or setbacks, and even height restrictions. And the height restrictions could depend on what part of the city that you're about to construct. You know, there's so yeah, that's sort of what the main thing with that, and then going on to authorities as well, as you're working through, and you have to deal with the authorities on what they want for the services, and then planning for the requirements to get construction and traffic management approvals. Then we move on to design and all the aspects of that's required. There's more interface between the disciplines, between the different engineers, and between the engineers and the architect. And then there's also the loads. There's increased loads, increased vertical load, increased lateral loads, which means earthquake and wind. The soil conditions, which was brought up before, on what we have to deal with. And so there's a whole series of things that we have to deal with that we wouldn't have had to deal with if we were to design buildings that are a low level. And then we move on to the services. That becomes more complicated. And fire, which is going to be brought up after, I think in one of the speeches tonight as well. And of course sustainability, which is the last point that I've spoken about, which is a requirement on every building nowadays. Construction. There's obviously greater costs, and safety becomes a real issue as well. And the systems that you have to put in to for safety. It's a constrained area, so you've got to really work out how materials are to be delivered onto site. I'm not sure what the situation here is in Sri Lanka, but in Melbourne, Australia, but in particular Melbourne, there's always a shortage of staff, and it's on how to deal with that challenge. And then there's meeting budget and program, and there's always continually rising costs on materials and also labour, and then making sure that the construction is aligned with design, so that when the building's complete, we can get that occupancy permit. And then the last point, when I talk about fit for purpose, I'm talking about that the client is happy that we've delivered what he wanted. And then lastly, operation. So the issues dealing with operation. So I've brought up a few case studies on what has worked and what hasn't worked, and my theme here is more about urban renewal. And one case is the Docklands in Melbourne. So this was a disused area. This was forming part of the Port of Melbourne, and which was used up until the 1990s, and then it was decided not to use this area anymore, and so it was thought that they'd renew this area with apartments and commercial buildings. It's located about 2 kilometres from the CBD of Melbourne. As you can see from that photo, it's on the water, so it does look pretty elegant, and there's yachts there, got those beautiful apartments, but it hasn't quite worked, and there's I've stated the reasons on why I think this is the case. I think the main reason, there's a lack of connection with the CBD and how it's all integrated. There's a lack of shops. There's hardly any schools as well. And the positives that I've put down is that there's a railway station, and there's also a sporting stadium, but they're on the edge of the Docklands area, so you still have to walk probably close to 1 kilometre to get to those from the heart of the precinct. So, and that's actually much closer to the CBD than the heart of the Docklands. But they're trying things, and one of the things that they're trying now is by building more apartments with what's called build to rent. So it's specifically for people to rent, with and also they're building a few schools within the area as well. So they're trying to make the area a bit more homely. So the case study 2 is I'm back onto, as I said, has worked successfully, and I think it's worked successfully is because it's what people want. There's with regard to the mixed use facilities that are within the building. It's close to the station. It's as I said, that you've got the tram outside. So people work, they go downstairs, they can have lunch. After work, they can go to the supermarket, they can go to the gym, they can pick up their kids from the childcare centre. There's also a wellness centre there, and then they go into the basement and drive home where their car's parked in the car park. So it's got a bit of everything, and and within it, it's got its own city. And also, there has been the Q building, which was sort of a noted building. Unfortunately, they had to knock it down because it was it was a hospital, and it had sort of got to a point that it wasn't able to be used in its current state. But there were a lot of lanes within that space, and they've also been able to, in the design and construction of this building, use those loans very effectively, and it's a very popular building. And that sort of just goes on, just stating a few things what I've just said. And then moving on to the what I was talking about before, build to rent. Richmond, which is 3 kilometres from the city, this is an example of where they've got the build to rent. And so you've got 368 apartments, and with some really high class facilities. Now the government has actually given incentive to the private developers and given them some quite substantial taxation breaks to engender these buildings, the build to rent. Like many places in the world, there's a shortage of living space, and so this is one way to encourage it with the build to rent. Okay, I'll just move on to the next. So yeah, this is the next case study is Metro Tunnel, which is almost complete. So there's 5 new stations getting built within the vicinity of the CBD, and actually 2 of the stations, but I've noted there Latrobe overhead site development, and you've got this big 55-storey office building with a mixed-use development downstairs, and that and again that's going to add more life to the city. Now when I talk about Latrobe, that's what the site's called above, but the station is State Library. And at Town Hall Station, they're building an 8-storey building above. What's interesting about the construction of that is that as they were excavating down, they were also building up. So for all of those that know the top-down method, where you're building slabs, putting penetrations into the ground and excavating down to another level and another level and another level, which is which was done to a lot of success in London, where they use that method on many of the stations, and we actually adopted that and here. Arden Station. So outside Arden Station, within a 400-metre perimeter, within the next 5 to 10 years, I think it's actually by 2031 or thereabouts. Now this project will be complete at the end of this year. They plan to have 25,000 extra residences. So this is certainly urban renewal, where you've got it's an old industrial area, and they plan to put up several apartment blocks there and create a new suburb within the area of the station and bring it to life. Yeah, because at the moment you can't say that it is lively. A lot of disused factories. All right, and now this is my final case, and I don't know much about Sri Lanka, so just bear with me on this one, but I did a little bit of reading, and one was particular. There was a PhD student who had written his thesis on Sri Lankan social housing and lessons to be learnt from other big developments that have occurred in around the world. And in particular, he was talking about Chicago, where they had people that were living on the street, and on what they had created there to house them. And it was, it turned out to be certainly a disaster, because within 20 years they had to knock it down, those buildings. It just did not work. One, there was a stigma attached for these people living in these areas, and there was the crime rate had increased within that zone, and so for a whole and for a number of other reasons, they thought it'd be best that they'd knock it down. And within his article, he does talk about the parallels between Sri Lanka and also Singapore, going back into the 1960s, where they had a need for housing, and that they were able to make it successful. And and what he's actually saying within the article is that he was able to what he was saying was that what Singapore was able to do was to get people that were on the street and living in slum areas and building new apartments, but rather than have a building where it was these people off the street all living in those apartments, it was a bit of a mix between people that previously had a home and the homeless. And it seemed, so what he's stating is that ended up being successful, and certainly no stigma attached to those areas where these homeless people were living. And obviously there's other reasons why as well. The government and also the wider community were working collaboratively to make it successful. And that's always hard, to get everyone on the same page on what the goal is. Okay, and this is on vertical schools and integrating these schools into the CBD. Sorry, I think these are the wrong set of slides. They're not the latest slides, but anyway, that's fine. I can still talk to it. Yeah, it's sort of integrating these into like vertical schools into areas where people live within the area of the CBD, where you've got everything close to each other, all the facilities. Okay, so then we move on to the opportunities, and pretty much a lot of what I've discussed, and if it's been successful, it's really come from government policy, where they've had a strong policy to work from, and everyone's worked together. And there were great words that were discussed earlier in our previous speeches, that things are only successful with everyone working together. And having everyone here and coming from all different parts of the construction industry, is a great thing, because you're getting a different view on what, or a different angle on what should happen. But if there's cohesiveness, well then that's the essence of success. But certainly there's got to be incentives given from the government, which I discussed previously, to business to engage, whether it's tax breaks or anything else, to engage in social housing. I'm not sure whether that's that relevant here in Sri Lanka, but certainly in Australia it is. And the government can't do it alone. They need business, but they've also got to help business. And then the wider community also has to support it. And something that I stressed in my previous slides was having a mixed-use developments. And so where you've got a combination of uses, and it's not just your apartment block that's built in an isolated location. That's never going to work. It's got to be amongst everything else, and that will be successful. So, yeah, and certainly that will that'll breed success. So there's certainly opportunities in vacant space or disused land where this can occur. And really what I've discussed is the essence of sustainability, because these buildings, because they're successful, will be around for a long time. And so because you've got buildings that people want to be in, it's close to transport, close to the facilities, and that's what we want. And so I suppose I'll just end by saying that things are done twice, in the planning and design phase and in the construction phase. And so really your success is established in the planning. Thank you.
Thank you, Mr. Adrian, for joining us all the way from Australia. We now present a video from one of our key gold sponsors, Langwa Sanstha Cement Corporation Private Limited, a name synonymous with strength and trust in the construction industry.
The Langwa Group acquired the pioneering Ceylon Steel Corporation in 2009, revamping and relaunching with Langwa Sanstha Vani as its key brand, manufacturing a range of industry benchmarked QT bars, box bars and round bars in a variety of configurations to suit market requirements and needs. Sought after and the choice of professionals across the island, Langwa Sanstha Vani is today the undisputed leader in the manufacture of going beyond the mere production of cement, and with the goal of maintaining the highest standards and specifications for quality raw materials and production processes. Langwa Sanstha Cement Corporation Private Limited opened the largest production facility of its kind in Sri Lanka in March 2022, marking a new dawn for the construction industry in Sri Lanka. State-of-the-art production facility located in the export processing zone, Mirijavila, Hambantota, incorporates a 2.4-kilometer conveyor system that links the Hambantota port to the factory, minimizing the impact to the environment. only state-of-the-art facility of its kind in Sri Lanka, is monitored by a fully automated control room to deliver cement products of the highest quality to the construction industry. The brand produces a wide range of cement products including Portland composite cement, ordinary Portland cement, and blended hydraulic cement. Is distributed throughout the island using the largest distribution network in Sri Lanka. Langwa Sunstar Cement Corporation Private Limited has also ventured into producing an innovation range under the Langwa Supergrades name that includes SLS certified tile adhesive Standard Fix C1 and Ultrafix C2 tile mortar, as well as skim coat interior and skim coat exterior to meet market demand. Langwa Sunstar Cement Corporation Private Limited has, in a very short time, achieved the distinction of delivering comprehensive cement solutions for large-scale commercial and industrial projects, having established a legacy of quality and winning the trust of Sri Lankans over many decades with Ceylon Steel. Langwa Sunstar Cement and Langwa Supergrades together are undoubtedly the foundation of construction raw materials in Sri Lanka. Langwa, a trusted bond.
Thank you, Langwa, for your continued support. Prepare to be captivated as we invite Professor Priyan Mendes. Professor Mendes worked as a structural engineer at Cornell Wagner for 5 years before joining the University of Melbourne as an academic in 1990s. He was involved in designing a number of skyscrapers in the Melbourne city skyline and landmark high-rise buildings in the world. He is both a chartered engineer and a fellow of Engineers Australia. He is a professor of civil engineering at the University of Melbourne and the leader of the world-recognized Advanced Protective Technology of Engineering Structures Group. He is presently the director of the ARC Center for Advanced Manufacturing of Prefabricated Housing, which is providing leadership to the Australian construction industry to use the advanced manufacturing and construction techniques to build modular and prefabricated buildings. Having authored and co-authored more than 500 journal and conference papers, Professor Mendes possesses one of the most colorful academic and engineering profiles of any Australian or world expert. Professor Mendes was presented with the highest accolade given to an engineer for his service to the concrete industry in Australia. He was awarded the honorary lifetime membership of the Concrete Institute of Australia. Professor Mendes has also offered his services to his motherland, and he is no stranger to both the Sri Lankan construction industry and academia. He provided the visionary leadership in establishing the Green Building Council of Sri Lanka in 2009 and was the founder chairman. His expertise in high-performance concrete and the design of tall buildings has been sourced for a number of iconic buildings around the world, including Australia's tallest building and South Asia's tallest tower, the Lotus Tower. He is also the honorary chairman of the Civil and Structural Engineering Consultants, which is the largest consulting engineering company in Sri Lanka. Along with Mr. Shiromal Fernando, he has been involved in many major projects in Sri Lanka. Please welcome Professor Priyan Mendes from Australia, presenting on Achieving Heights, Innovations and Materials Redefining Modern Construction.
you, Ronali, for that very kind introduction. And also, I have to say that it's always really, it's an honor and a privilege to come back to where I was born. And in fact, I want to spend more and more time here. So last time when I went back to Melbourne, they were asking me, are you visiting Melbourne this time? So, sorry. So, no, actually, in fact, I have been a senior academic now, and I have a bit more freedom. I don't have to do lecturing, and I have other people doing a lot of things, so I can spend more and more time. Where I want to really also be in the, again, thank you for that kind introduction. It's really to be on ground doing things. That's what I like as well, not just research, which I have been there for so many years as an academic. So now that, like now I have a bit more freedom. So again, to give him the opportunity here, he doesn't like this, but I had to acknowledge Mr. Fernando, who gave me the opportunity to be here and to, when he started the CSEC company. And that's really that where we have been doing many things here and actually going to other places as well. So coming back to my beginnings, I'll be very quick. I don't want to take too much time, but today is it's a bit of blitz where our future, where we are going in the future, rather than we can learn from the web and a lot of things as well. Thank you very much for my very good friend, Mr. Adrian, gave a excellent talk, and to be like to be in a very short notice. He had to cancel a trip somewhere to be here. So that's really, really, thank you again for being and helping us and giving that excellent speech. And it's actually involved in many major projects. You can ask any type of project, infrastructure projects, to buildings, to many other things. He has been there. So we can't have a better person than him talking about some of these topics. My beginnings, I will not go into that. Starting from my career with the Telecom Corporate Building, 65 MPa concrete. First time in Australia, we used high-strength concrete. And then to talk about the other ones, my journey later on, and to also this new prefabricated thing. It is not new now. When I started that in 2015 in Australia, to be really working on the modular prefabricated construction, it's been 10 years. I'm very, very happy that it's coming here as well now. So I can talk about a lot about all that, but I won't have time. I will skip some of that and then go into really to my talk. But I also want to acknowledge that, again, this sort of forum where we could bring all different disciplines together who are involved. And we are very, in fact, we have to be very proud to have, actually I can't read, it's a list is too much to read. I don't want to miss any. So we have the chairs of and the leaders of IESL, engineers, the Architects Association, the Quantity Service Association, the Green Building Council, Chamber of Construction Industries, and also with our special invitation, I had to thank our fire chief is here, Mr. Wilson, and he's leading he's really saving our lives here, being there, so thank you very much being here. And also, actually I had to also acknowledge, I think he's still there, Mr. Nishant, who is running in a different industry, hotel industry, chairman of a well-known hotel in Colombo. And also, actually, I want to thank all the sponsors, the major sponsors. We can do all this is because major sponsors to all the sponsors there. But also, it's sort of refreshing to have different industries. We have been in the construction industry, and I had to really thank my friends, Mr. Shiran and Ms. Nisha, who is actually she's a TV person as well. So, being here, bringing the industry, insurance industry, to these sort of forums where they are involved in in fact, I think there's a video later on. I think we'll listen to, because it's good to bring other industries as well to these type of forums. So I have to acknowledge that as well. Coming back to my talk will be very much a blitz of future. We have future where we are going. So this is my story, my life story reaching the clouds, and to be, it's a long journey, and with the, now it's about, I think, actually I shouldn't taste too much, then my age will get exposed. That's okay, but so it's a long career, and I've been starting as an engineer and going towards academia, which I never stopped working in the industry, and as I already acknowledged, to be here and to have the privilege to be in the. I learned a lot from being being sort of part of workshops to like in the world's tallest building, the Burj Khalifa. My work is on. I don't want to say I have done everything they have anything, but it's just high strength concrete columns are based on my work there, and a few other things I did for this building. It's a unique building, still the tallest, and no one can beat still. And then actually it was mentioned by I think architect Nirodha, about the Nakil Tower. That is a Nakil Tower, which is 1 kilometer tower. Again, to be privileged to be part of a team of designing this Nakil Tower. My work was more on wind engineering to other things. Today I'm not going to talk about that part, but I had to say this one. The foundations are done, and then the financial crisis came. So $150 million of foundations are buried under the sand. So hopefully it'll come back. Nakil also had some problems after that. But anyway, it could come back. Also, I put some innovations in this building, that is some slots. You can see I hope will be built because I put some slots in the building so that to reduce the wind loads. That was accepted by the large team. Very hard to get through to people to change certain things. And that was because I did a bit of work on the wind engineering of that. They accepted my concept of putting that. So coming back to get into my journey, very quick journey, I would say Shanghai Tower, second tallest building, 632 meters tall. And I learned a bit of Chinese writing. I gave a talk in Shanghai. So still that slide is there. So it's one of the best buildings in the world now. It's twisted every floor. You may have listened to me talking about this building. I can talk for hours. But the work was, that's my friend, Mr. Gong, who's a project director who built this building. And I was involved with him. They were topping up the concrete, 507 meters, I think, if I remember correct. And that's, I was really helping them with some high strength concretes and pumping concrete to these levels. We had to use some small aggregates to really get the workability. I'll leave that to another day, that talk. So this is also, this is going to be the second tallest building in the world, the Merdeka Tower, which is really the Kale, you can see some 679 meters tall. That's not open yet. It's going to be open probably this year. No, I don't think it'll be 2026. This was when I went there last year. So anyway, Mr. Tenko is the developer, like PNB, the developer, but the director of development there, who right now was recognized my effort there. It is already reaching the clouds. So that's my journey in there, but we can't avoid that. This was shown. Very proud of this achievement, where in the world stage we got one of the best awards in 2023 in Singapore. Mr. Shomal is there, I think Mr. Kitmal there, and our Kampi is there as well, taking the award there, and with General Prasad for the Lotus Tower. So it's an outline with basically looking at in a brief way. I will not read from the slides. You can all read from the slides, and so with the discussion on where we are heading, and with a brief outline, and I'll give that opportunity. And we all are meeting. I don't want to talk too much because we are after the break. During drinks, I'm happy to. We have any questions from all of us, we can discuss. So very briefly, these are the issues with the construction industry. I'll get it's easy to read. Just get my notes of the couple of slides in here. it's easier to, okay. Yes, so with the construction industry, with the again, let's put down these problems. We all experience here in the construction industry. So what are the problems that we are, when we put together the problems and the project delays and cost overruns? We can talk for hours and hours about that. Let's be brief. Going vertical, we need to really have to really address all those things. And correctly, Architect Nirodha pointed out the difficulties. Efficiency is going down with going vertical. However, we have to find the solutions. And that's where I think it's a challenge, as you mentioned, rightly pointed out, we need to improve the efficiencies. We don't have any space. So China, Singapore and all that compulsory to really build tall buildings. You can't really, you have to make a case if you want to make a smaller building. It's happening here. Colombo actually, what's the point of building a 5-story building in Colombo? You know, we don't have land within the middle. So it's really, it's going to be vertical and it's going to be up and up. But however, we need to address these issues. I put down very briefly these ones. Maybe another day I'll talk in detail. I put down here some of the problems, project delays and cost overruns. And we have talked about material shortages, procurement is a major issue, and the non-conforming products. That's where we spend a lot of time on the cladding, which I have given talks on the cladding side, where the aluminum composite panels came and the plastics were burning. And every flow, every minute, one flow, if the fire spreads, as Mr. Shomal also mentioned in his opening talk, the cladding issue, which we need to organize another talks. But non-conforming products. Australia went through major issues of the non-conforming products. Now it's tightened up too much. That's the only problem. So we're trying to really improve the quality of the imported products and all that. So there are two things have come, because I don't have time to talk everything. So I'll say that two things are determining the materials now. One is really one is with the non-conforming products like the fire and combustible products to many other low quality products. And also second one is the EPDs are coming. Today, I'm giving a talk, another talk for Green Building Council. Maybe, no, that's on a different topic. But the EPDs are the environmental product declarations. EPDs, every material in the world now would have EPD number. That's the carbon numbers. So you have to have all that. If you as a material producers, we have to have EPDs. There are, I think EPDs are coming here as well. It's essential. We'll see it's coming here. So EPDs are there and so on. So with the quality and the performance issues, I put down in briefly you can read from the slides there. I won't go through that. Quality and the performance issues are there. And already Mr. Adrian mentioned about skilled labor shortage. So I'll skip some of the detail there and get into where we are. So with how we build faster, cheaper, better quality, safe and more sustainable products. And so again, that getting on with the advanced building techniques, as I said, I'm actually today taking you to the future a bit more rather than present construction. We all already happening as well, so we can learn a lot from. There are so many experienced people here, so many as well. But however, looking at the future a bit more with the 3D printing, which I have another slide, that's where we will see a lot more in the future, next 5 years to 5 to 10 years. And the 3D printing side, I'll have another slide. On-site 3D printing as shown here. The lab, we can do anything. Now we can print anything these days. Like now we have done PhDs. I've had so many students around the world have studied 3D printing, materials we can do. But get into the field. Now my group is, I call lab to field. Basically, get into the real field just from the lab. So with the labor cost and the timelines, all that, there are issues. Drone is coming in a big way now. It's already, I think some things are happening here, but drones are getting more and more being occupied, being used for the going vertical, some of the tall buildings. There are security issues which had to be addressed, but however, the drones, these days, this is a joke. I have to say, when I talk, I have to say something as well, but these days drones are used more to observe your neighbors' houses. That's all. It's a joke. But so when getting taller and taller, drones are used, and with the accelerated project timelines, it's in the slide there. So getting on, and this one is where closer to my heart, which I say a bit more. We have to, I think Adrian has mentioned this, but we have to get to very quickly do the construction. Construction costs are going up, the labor costs, all that are going up. So we need to do this as soon as possible, construct. So prefabrication and modular construction where everything is done in a factory and brought to the site. There are, which I have some slides later on that. And the other one is about the sustainability, where we have talked about the sustainability a lot in different forums. And we all know getting to the green buildings, the green design. One comment on any tall buildings, even recent ones where I have attended workshops. First of all, those days it's run by us. Basically, us means engineers, architects, quantity surveys, everyone running the workshops first, tall buildings. Now, the first is the environmental consultant, ESD. So they start other way around. How can we get the best rating for this building? And as mentioned, thank you for the introduction. We know since 2009 we have a long journey. I think Mr. Lionel is somewhere as well with manager Green Building Council now. And with I think that sort of things are so important, and Architect Jayant Pera, the chairing now. With the green buildings are coming in a big way. Every building, I was in the Singapore sessions, Green Building Council APN sessions on last Monday, and representing Green Building Council of Sri Lanka. And actually, we talked a lot about tall buildings as well. Every building, they are asking now the platinum ratings to 6 ratings to 7, and we have the Sri Lanka, the local rating system, which is really very efficiently running. So anyway, green buildings, I will not talk today. That's for another day. Energy efficiency, we already know about the future things there. And so I put down that. Where we are heading is a materials revolution. That's where actually I was asked to talk about that topic a bit more, but the smart materials, and this is something which really, for the future, I put down only 2 things. So many things are happening, and these 2 things are quite important. I'll have another slide on self-healing concrete. We have done all sort of things, the concretes, but the self-healing concrete will be, we can look at the self-healing concrete in the next 5 to 10 years, and it could be, it's already coming. And with I have one slide on that. Other one you will see, it's an interesting one, will be a color-changing materials. We see the facades, some materials. I had to say, I had like a pilot project with a master's group trying to do something with early stages. This all interests me a lot. Color-changing concrete is where the color-changing materials, in this case, is really to, like during the day with the sun, it has a color, it changes the color. So changes the color and going to a bit of a brighter where it absorbs less heat. And at night time, the other way around. So so that we can see the color changing the materials coming in next few years. Keep an eye on that. And the other one, as I mentioned, there are a few others I want to talk about, but just want to touch on this one where the area which is a bit closer to me, that is the self-healing concretes. I will not go into all these technical details. On another day, I'll talk a bit more detail on what are these different self-healing methods, the vascular methods, tubes having biomimicry was mentioned, that having we have our veins and everything. So it's similar to that. Through the concrete, we run some veins, have the self-healing when there are cracks, and the capsule-based safe healing methods, and also the last one, which the shape memory alloys can be employed to do that, bacterial or microbial self-heating concrete. That one we can look at it. And a bit more detail, we'll see a bit more in this material revolution we are seeing now. And because, as mentioned, to go vertical, we need to do something different. We can't just really do whatever we do now. And the other one is the other one I didn't mention. It is a thermo, really, again, we are doing some thermoelectrics through the concretes and the walls and all that. That is really, there is one paper under our name, my group name. There are a few others, I'm sure, doing it as well. That's something to look at. And then anyway, that's a brief. Towards achieving heights, we are getting to 800 meters with the Burj Khalifa, and with getting to 1 kilometer, we mentioned Jeddah Tower. Jeddah Tower is stuck now at the moment, as mentioned. They mentioned this one. It's really, and I think there could be a start there. We always talk about we'll get an update this time when we go to the conference. But every time they try to say we are going to start the building, but it hasn't happened. So with this is very interesting, the talk on 10 kilometers. What I have worked with up to now is only 2 kilometers. This really have, again, that's not the one, I'm not allowed to say which it is. But during the COVID, they got hold of 23 experts around the world. I was lucky to be there to talk about. My task was they're the best around the world, but the materials, I was asked to say, can you develop materials to go 2 kilometers tall? That was my task. There were others doing the best experts in the world. But so that experience was very useful. That was a feasibility study. And one day, hopefully, we will get to that 2 kilometers. And I think maybe even here, we may get to some heights. And I know at least one developer is interested in going, having the tallest building in Sri Lanka. Hopefully we'll get there with a bit more higher levels. So how do we do all this? And it'll be very brief on enabling the technologies. I will not go into these technologies. There are so many things that even my group and wider group have worked on a number of things here. I put down in very briefly these ones, some of the technologies. I'll leave that to another time to talk about. I'll be very brief with this one. And with the construction industry, as I said, uses 1/3 of the emissions of the world. That's where the opportunities and challenges are. We are 2050, we say net zero. We now call it net zero construction now. Net zero is 2050, but we can't wait until that time. Next 10 years, we need to achieve that. We are a bit behind. Our temperature rise is 2 degrees now. We were supposed to be 1.5 in 2050, but now at the moment, the estimate is 2 degrees. So we can't really do that. Again, I leave that to another time for another talk and given some talks there. But we need to work on these, the concretes and steels and all that, because they are the most consumed materials. And moving on, that has given us opportunities. Basically, these are all opportunities. And I don't think I would have continued a lot of research if we didn't have all this. So now net zero concrete is one of my main research areas. And with oh, sorry, I think I'll go back to that. I skipped some of that, went back there, last slide. That's okay. No, I will not. It's okay. I just no need to go back. I just want to save time as well. I normally want to, when I'm given a time, I want to finish in that particular time. But let's see how we go. So with so this one thing which really now putting some bit more detail. Today is not about detail. As I said, there'll be a bit of a revolution happening in the materials side. We are using less cement now. Optimization of structural elements. We had to just go hand in hand, materials and optimizing structural design. We can't just focus on the materials. And the again, recycled concrete is a good example. Use of cementless concrete. I'm allowed to say this one. The last grant I got with a professor in Sydney University is on carbon negative concrete. I don't think anyone has worked on carbon negative concrete. I'll leave that to how we are trying to do that. I will talk about it another time. We just started the project, so we are still going from positive to zero. Then we want to go into negative, and we got very good ideas there, and to really how to do that. So maybe some of my students will start talking about that in another couple of years. So other one which really is happening is the clinker content, which is really we know there are actually very good cement manufacturers here. One is a sponsor here as well, but is the major sponsor. But using the supplementary cementitious materials are essential now. We need to waste to substitute. I'll have a very quick ones. This is very close to. This is because my friendship with Mr. Adrian, we managed to get this one. Most difficult task is to get to the industry, these waste materials. Both of us started doing in a metro tunnel project. He was the senior design manager for the metro tunnel project. And we tried to put the glass in concrete. And that's a huge achievement, first in the world, in a large infrastructure project. So I don't think that, I think our friendship got to that, some of these achievements. And in the real, we can do this in lab. I can very easily do in the lab, but how to get it to go to there? Again, he's, now that Northeast Link, Mr. Adrian supported, this is something that one of the companies, my good friend, we are very proud to have Mr. Ravi Dishanka as the IDB chairman. I know we were talking about all this entrepreneurship and all that. So this is one of the companies that I helped to start, like Mr. Niraj, I had to help, like say he invested $7 million or whatever. That is to really solar panels, to recycle the solar panels, because we are, that is the name I gave their Solarcrete there. And actually, I think he may make a bit of money from that. I don't think I'll get anything from that, never know. But now first time we put in Northeast Link project, trial out this, the solar glass concrete. So these are new innovations we'll see. I don't think anyone has done in the world this, putting solar glass into a real project. Let's summarize certain things, because I think I'm running out of time. High performance materials for the future. We need to really look at the performance of all that. Lightweight concrete, you will see a lot. High strength concrete, of course, we talked about. And the acoustics, the durability, I will not go into all that. Fire resistance, Dr. Pasida will talk about that. I'm proud to have an association with Dr. Pasida a bit of time. Affordable and environmental friendly, durability, acoustics, and all that. And I can talk for hours. Maybe I'll leave it to another time. And we go to the bit more closer. That's how it was mentioned. Actually, thank you, Mr. Arian, mentioning this. We have gone to a bit of commercially looking at about 200 MPa. My high-strength concrete journey is from their beginnings, to where I led the code committee, Australian code committee, to get to the high-strength concretes. We are now 120 MPa, but commercially 150 to 200 we can do there. And there are ways which I'll leave to another time at how we do these things. But the next one, which really, the high-performance graphene concrete, the Graphicrete, where the Sri Lanka, we are very proud to have the best graphene, the vein graphite, the purest, really the graphites, and we are taking the opportunity. So graphene to concrete, again, I can give a talk, I can talk about for so long. And I think that we have to really, it's actually, again, a bit of friendship with Mr. Sharan Anakara, LOSC, which gave me this opportunity to get into the graphene, and he encouraged me to, he was like, to really help them out with the CGT, when he started the Graphene Limited. With the Graphicrete, which really the name I gave for the graphene concrete, and Mr. Shumal went and put that in his CSEC building, the first time, I think, in a field application. The other thing that he did was to put all the waste materials into one of the slabs. We call it fruit salad slab, It's really all sort of waste materials. Everything is there in that bottom slab of the building. That's really another achievement, using waste materials. So how do we do this? This is a very brief presentation, Blitz. Rapid construction, we need to do the low carbon materials and the performance-based standards and specifications. We can't just run with the codes and standards just the way we are doing it now. We need to go performance-based methods, and I'm sure Dr. Pasadu mentioned this in Stock on Fire. Performance-based, we are going a bit more on the performance-based, and with the low carbon materials plus rapid construction. Rapid construction is a key. How to get it done as soon as possible. And then we need to look at the performance-based standards and specifications. And I think there's certain things happening here as well in that space. So bring all that together. That's where we had to do that. And let's go. I think I'm running out of time already, right? Yeah, that's okay. Okay, we'll be very quick. I can talk for hours, but my alarm is already on to say my time is up. But on-site, so really performance-based, we can't just use the normal codes. Finishing off, oh, yeah. It worked before? It's okay. Just, yeah, press the button. So it is really where we are going now. On-site 3D printing, not in the, like somewhere else. Bring these robotic arms. We have a trial arm in one of our labs, and to really get it to the field. I think that's where we see a bit more development. And some of the builders are starting to think about this technique, and so early stages. Prefabricated, we talked about prefabrication already, so I will skip that. And doing these modules, bringing the modules, we have in Melbourne, especially one of the best, highest modular buildings in the world. One of my friends, I had some involvement in this, but with the La Trobe Tower in Melbourne, where one of the first modular buildings, we both know Shan Kumar very well, is born here. Someone born here. We are very proud of him to have done that building, the innovations of that building. The next one, you'll see a bit more even here and other places. Already Australia is very well, in fact, almost all the buildings, they do these pods. They bring the kitchens and bathrooms and all that done in a factory and bring it to the site, just to save time, huge amount of time. We have done research as well on that. There's a talk on the YouTube where the talk I gave in AIT Bangkok during the actually COVID, so I couldn't go there, and on the Meet the Expert series. It's in the YouTube. So, and the other one, again with the Mr. Chomalos mentioned this, but for me to mention about mass timber, but I think timber is coming in a way, the hybrid structures. Now we will see a bit more timber in the world. And I got 4 PhD students. I was in the World Timber Conference from here a couple of weeks back. I went to Brisbane. So we had some discussions on the mass timber. That's coming in some way. Timber is a more sustainable material, as we know. So it's difficult to do it here yet, but I think the hybrid structures, we'll start putting some, I think there's some timber here, of course. We have a long history, kings and queens times for timber construction. So we go back a little bit. Maybe we go vertical. I think timber is another material we can't miss. And I'll leave that to another time to talk detail. We talked about where we are heading, new opportunities are there towards net zero in 2050. And that's the theme of my work, the pushing limits there. That's not my structure, but that's from Portugal. Concrete also, we can do anything. You can see on the left-hand side. This has been actually done, so we can do many things there. We can have innovative materials to structures and smart. I already talked about the 3D printing and the construction 2040. What will it look like? In 10 years back, we thought, we have 10 years to net zero, all that. Then now the 2030 is coming. 2040 will come, and there are a lot of younger people. We are very happy to have younger people. You will be running the show at that time, mostly, right? So at 2040, what would be looking like? I have to say, one thing my wider group is doing, that is the AI can help to detect the unsafety behaviors on the construction sites. Construction safety, I think, Mr. Adrian also mentioned, mentioned about this construction safety side. You have done a lot of work on construction safety. So how AI will really help, with the vision technologies. I'll leave it to another time what we're doing there, right? On the AI side. I think we are going to have a digital construction workshop at the end of this year here in Colombo. So maybe we'll leave that to that time. It's a very interesting project, this one, I can tell you. Having the visions and so that people are, this is a joke, but they said, we get blind when you put all this, but so it's unsafe. It's not that at all. It's safer. That's a joke as well. So coming back to digital twins, I think we did have AI last year, so I will not go into that. A bit more. AI is really digital twins is coming in a big way in a construction site. This is a trial project we did in Canberra, and that where we had the digital twins being done, and then did the monitoring. We did this one, and with I don't spend all my time, but there is a wider group doing this work. So on everything like this, but so we did monitoring and all that of this ANU, the university. This is where we are heading with digital twins. Oh, sorry, it went back. No, that didn't start. Yeah, it's okay. That's okay. I have a video there. This one should start. No? That's okay. It did before. Can you do it from there? No. Oh, no, it's okay. Oh, no, I think it's coming. Maybe. Next slide. No, it's okay. Oh, no, I think you saw this before, but I want to just say that's where we are getting the AI, the 3D, the digital twins, monitoring the site, and also there'll be CCTV cameras doing all the monitoring. That's where the future is. There are trials being done, but it's going to come in the future where all the data being collected, the procurement, the material handling, all that there'll be through the everything will be monitored from a digital twin, which is a digital twin is something which really have be done with the same thing in a digital form. So with now AI will be incorporated as well. I'll leave that to another time, and I hope this one works.
Thank you very much, CTBUH Sri Lanka Chapter Committee, for inviting me to give this talk, and all of you for listening to me today, and congratulations on this absolutely magnificent topic on vertical vision, and really look forward to be here next year as well.
Thank you, Professor Priyan. It's always good to have you here in Sri Lanka. We now present a video from our esteemed gold sponsor, IIRM Lanka Insurance Brokers Private Limited, ensuring confidence and coverage for the future.
Across our cities, development is reshaping skylines and redefining what's possible. Every day, new structures rise more ambitious, more complex, and more essential to the growth of our economy. From landmark commercial spaces to vital infrastructure, construction is a symbol of resilience and progress. In the world of construction, every project involves risk. At any stage, unexpected challenges can impact people, property, timelines, and investment. Natural disasters, accidents, and liabilities can disrupt progress and put entire projects on hold. That's why having the right insurance partner matters. A team that understands the complexity of your industry, who can assess risks across every phase, and create solutions designed to protect your ambitions and safeguard your investment. As your insurance partner, we create customized insurance programs tailored for construction businesses, aiming to protect both material damage and liability risks. Whether it's navigating complex construction all-risk requirements or designing a liability insurance program, we have the ability to put a custom program in place to manage the unique requirements of your business. When working with you, we ask the right questions, go through standardized checklists, and get a full understanding of your construction business. We help you manage risks before issues arise, and when you do happen to have an insurance claim, our full-time claims professionals ensure they are handled quickly, efficiently, and correctly on your behalf. We are true advocates for our clients, and we have strong relationship with the insurance companies to manage your claims and represent your needs in the best way possible.
At IIRM, our mission is simple: to protect your people, to protect your properties, and protect your investment. We serve over 1,000 customers per year, and we place 11,000 corporate policies. We manage 3,000 claims per annum. We have a team of over 40 qualified staff who brings expertise in insurance, including property, engineering, marine, liability, and employee protection. Behind every structure, there is a vision. Every vision needs protection. We are here to help you from groundbreaking to project handover, whether it's simple or complex.
IRM Lanka is a subsidiary of IRM Holdings, Singapore, having associate companies in India, Maldives, and Kenya. In today's global business landscape, IRM delivers smarter insurance solutions backed by strong international reinsurance partnership with markets in Dubai, Singapore, India, Africa, and in USA.
Wherever you bid, whatever you envision, we are here for you. We will take care of you. IIRM, your partner in protection, representation, and peace of mind.
IIRM, your trusted insurance partner. Call us on 011-7589-601 or 0763-772-321. Visit us at iirm.lk.
Thank you, IIRM, for supporting this forum. To conclude the keynote segment, we welcome Dr. Pasindu Veerasinghe. Dr. Pasindu is a senior lecturer in the Building and Structural Engineering Division at the University of Moratuwa. He holds a bachelor's in civil engineering from the same university, graduating in 2015 as the most outstanding graduate of the Faculty of Engineering. He completed his master's in 2016 and later earned his PhD in structural fire engineering from the University of Melbourne in 2020. During his doctoral studies, he was affiliated with the Centre for Advanced Manufacturing of Prefabricated Housing and contributed to several industry-funded projects. He was also part of the Innovative Facade and Fire Engineering Group, a leading research collaboration among the top Australian universities. He is the founding president of the Society of Fire Protecting Engineers, Sri Lankan chapter. His research focused on structural fire engineering, fire safety, performance-based fire design, concrete technology, and modular construction. Please welcome Dr. Pasindu Veerasinghe for his keynote speech on high-rise, high-risk, rethinking, fire safety for tall buildings.
Right. Good evening, ladies and gentlemen. And it's my honor and privilege to be here this year as well. And if you were here last year, you would remember that we launched our Society of Fire Protection Engineers Sri Lanka chapter at this same moment. And we made you a promise that we will, do three things. That is, one thing is creating this professional body for a profession of fire engineering. And secondly, collaborating with the government regarding upgrading our fire engineering standards. And thirdly, promoting continuous professional development or education and awareness about this importance of fire engineering in buildings. And I'm happy to say that we have come a long way during the past year. And I thank CTBUH Forum as well, because it is the place that we have launched and we got the momentum, and I will be happy to tell some things that we did during my presentations as well. Now today's topic, now a lot of different speakers speak about going tall and tall, and there's one thing when you go tall and tall, as you go, as my topic suggests, high rise, and there's a risk factor involved as well, structurally, other factors as well, and also a fire plays a major, risk factor when you go tall and tall. So my talk will be based on that, and what are the risk factors and how we can mitigate them, and also, what is the way forward in addressing these issues when it comes to tall buildings. Now, as engineers, we learn from disasters, and now if I highlight some of the key disasters that happened throughout the past few years, 2014 there was this La Crosse building tower in Australia, which made the academics and the engineers aware of this importance of fire engineering. And 2017 Grenfell Tower, which was like a global event that was an eye-opener for all, like many professionals and government bodies as well. And it was life-changing event for most people, including me, because I was at that time studying, about 3 or 4 months into my PhD under Professor Priyan Mendis. I was studying about modular construction, and this happened in one of the nights. And the next day morning, I hear Professor Mendis giving a talk in one of the radio channels about this one in Australia. And the same day evening, he came to me and asked, Pasindu, would you like to do more about fire engineering, because I have done this few years ago, but with this now I think we have a good opportunity. So what do you say? And I was like, I didn't have any idea about that, what is fire engineering, because we don't learn it about in our undergraduate degrees. But anyway, I took the challenge, and he also guided me and my co-supervisor, Professor Kate. So it was a life-changing experience for me after that. So learning about this new thing, and we did a lot of work there in Melbourne, and while after I returned to Sri Lanka, I wanted to do the same here as well, because it is something new, new area that we want to touch. Right. So then 2019, this Bangladesh, so Grenfell Tower had 72 fatalities, Bangladesh 125, and this Taiwan building fire 46 deaths. Then in USA, apartment building fire in 2022, 17 fatalities. And in China, 15 fatalities, recent one, 24. And 2025, this Marina Pinnacle, luckily no deaths, but when it comes to Dubai, every now and then we hear a facade fire or a tall building fire. The purpose of this slide is actually, you can see it is, it represents all, most of all the continents in the world, and it is happening more frequently ever so. So then what are the common things that is there in all these fires? So I will list down 4 common observations or key things, and then I will base my talk on those 4 common areas. One, the cladding issue, the combustible cladding, and the danger of cladding accelerating the fire spread in high-rise buildings. That is first thing. Secondly, the evacuation challenge. As you go higher and higher, and often occupants have limited escape routes, and the evacuation is slow and challenging as well. Challenging of evacuating so many people within a given short period of time. Thirdly, the firefighting. I mean, the fire chief is here as well, so they would know that as you go tall and taller, you have logistical challenges, how to reach the top of the building, and also firefighters, they have to access and climb all the way up, so there are a lot of challenges there. And finally, the effect of wind. So wind complicates two things. One, it is accelerating the fire spread within the facade, and also it complicates the smoke movement. So under these four categories, I will base my talk. And now, I mean, going into some technical details, the cladding issue actually it is the loss of compartmentation due to this cladding, because compartmentation is keeping a fire within a closed space. But when the cladding gets gets combustible, it spreads without any limits if the proper mechanisms are not there. And the evacuation, always the vertical evacuation is inherently slower and riskier. We'll discuss more about that as well. Then firefighters, they have limited ladder reach, and they need to hold their equipment to multiple floors. They need to go, and they have fatigue as well, so there are a lot of issues there. And finally, the wind and the effect of smoke due to wind. And you may think that the heat is the number one cause. That is not true. Actually, smoke is the number one cause for all these casualties, mostly fatalities. So we'll discuss under these four topics, starting with the cladding issue. So if you look at this diagram, this presents the number of fatal cladding fires starting from 1990, and it goes in an exponential curve, as you can see. So which comes us to think that whether our current approaches to fire safety is keeping pace with the increasing height or complexity or occupancy of modern buildings. Every now and then we change our designs and we change our materials, but we don't change our fire regulations with that. So what is the reason for this trend? Now, when it comes to cladding, I mentioned that there are two things about when it comes to cladding. So one thing is how we contain the fire, because the first principle of fire engineering is compartmentation. We can't totally prevent a fire from happening because that's an accident. But once a fire happens, the purpose is to contain that within a limited space. So we contain the vertical spread, the horizontal spread, and the spread to the nearby building, and also spread to the next level. So internally we can actually control, we have some control over that, but if it escapes to the facade, then what are the measures that we have to prevent it from reaching the next level? So one thing is this minimum spandrel height requirement to prevent the flame from jumping from one floor to the other one. So we have to have a minimum spandrel height, so that, for a given condition, the flame will not reach the upper level, so it will be contained within that compartment until maybe it is extinguished and the fire is controlled. And the tricky thing about this cladding is if it reaches the cladding, even if you have the required spandrel height, so the certain features of the cladding make it difficult to control. So that the external fire spread can cause secondary fire on other floors. So some factors that contributing to the external spread is the one thing is if you are using combustible material in your facade, which has happened in Grenfell Tower, once it catches, it is like a fuel covering your whole building, right? That is waiting to be burned. And the cavity in between the facade and the building, and the fire spread through a cavity and fire spread through a normal ventilated space is different. Actually, some cavities accelerate depending on certain conditions, some cavities can decelerate. And the wind, so once it reaches the external, the wind can be beneficial, or wind can accelerate the fire as well. And the other external fire incidents that can be contributing to this. And one thing about this combustible cladding, when you go around Sri Lanka, hopefully not in major projects, but in certain buildings we see these aluminium composite panels, right? So although the aluminium is not a combustible material, the sandwich in between the polyethylene core is a combustible material. So if the aluminium panel fails due to the heat at around, let's say 400, 500 Celsius, then what you have is the exposed fuel, which is like waiting to be burnt, which goes throughout the building. So there are certain risks on that as well. Now, under each condition, I will give you some examples that has happened around the world, and hopefully, fingers crossed, I don't have any example to show from Sri Lanka yet. I hope it will be the same for the years to come as well. So the Grenfell Tower, the cladding actually, the fire occurred in the 4th floor, and the cladding caught fire, and after that, it has spread throughout the building, like it's like an inferno. So it started from one page, and it spread both horizontally and also vertically. So which I mean, within a short period of time, you can I mean, see the time intervals that are given. So within one route has completed within about 5 minutes, the other route another about half an hour. So that is a very short period of time if you are trying to act as a firefighter. And now these figures show you, I mean, with the timestamp, how the extent of damage. I mean, you can see from the initial, it started very slowly, and it goes in the vertical direction, then it goes in the horizontal and both vertical, and ultimately, this is what you, this is the aftermath of that. So we'll discuss more about that, but you can see how devastating that is. Structurally, it is still there, but unfortunately, it has caused a lot of fatalities. So what are the measures that we can take to mitigate this issue actually? So one thing is actually not to use any combustible material in the first place in your facade, because you never know when it catches fire, it's very difficult to control. So using non-combustible material, and if you have cavities, the use of cavity barriers will prevent your fire traveling through the cavity and reaching the next level. And of course, sprinklers, if you can control the fire on its source itself. So according to these statistics from the NFP, you can see 90% of the time ignition is indoors, and 95% of the time sprinklers has worked. And most importantly, 97% of the time the sprinklers has controlled the fire without reaching it to the cladding or the external, the other compartment. So having sprinklers, I mean, is very beneficial in case of controlling fire. And finally, now we can't tailor every, I mean, we can't have a prescribed method that is suitable for all the buildings. So we have to have like some tailored solution for certain applications. So that is where this performance-based fire design comes in. So either we can test our facade arrangement, the small scale or the full scale, or you can do a, I mean, simulation and see, I mean, what is the time it takes for the ignition and the flame spread and how far it reaches and what are the consequences and so on. So this is a model that we did, and you can see there is a that is called the chimney effect. If you have a U-shape like space within your perimeter, and if you have any combustible material there, quickly it catches fire and it reaches the top level very fast due to the chimney effect. So we have to be mindful about these things. Now I will come to the testing later as well. Now when you are testing a facade or a wall or any component, we have to test the system, right? Not just the component, because what we, at the end of the day, what we install is a system along with the joints, the insulation and the connections. All things should be tested, not just one component of it. And then you will ask like, okay, where to test in Sri Lanka? So unfortunately, I have to say that we don't have any testing facility here right now. But that is the role of SFP now. Right now we are trying to, we have proposed an action plan of fire safe engineering for the Ministry of Local Councils and the ministry which covers this fire brigade. So one part of our plan is to have a national fire testing lab, maybe independently or under university, so which we can use these testing facilities before you put up something. Actually you can test rather than spending so much money taking your samples abroad. And secondly, evacuation. As I mentioned, now evacuation is difficult. If in case of fire, if your evacuation path is blocked, then the nightmare comes in. So some difficulties, challenges are you have to have long escape paths because of the height, and you have different types of people, elderly people, children, and persons with disability. So we should cater all of them in our rescue operation. That is a challenge. And limited egress routes, so often only 2 stairwells for dozens of floors, and also if one or the stairway get blocks, what happens? What is the next fail-safe method? And then residents often underestimate the alarms and wait for the instruction, and also they may get confused during these times if enough trials were not conducted. And finally, the gap between the design versus reality. So we propose a lot of things, but in reality, maybe your fire staircase may be blocked by illegal storage, or maybe your ventilation or the smoke control system may not work at the end. Right, again, tower. Now this, the right-hand figure shows you initially where the people were, and then finally where they found actually the bodies. So you can see, the people who can evacuate, few people came down, but actually some of them were killed as well. But you can see a lot of fatalities are towards the upper floors of the building. Why? Because the evacuation path or the fire staircase got blocked during the fire with smoke, so they couldn't come down, so they went upstairs, and eventually the fire has reached upstairs. And as Mr. Shiroma showed one of the videos, people started to jump from there. Maybe the ground floor, actually, some people are the people who have jumped, and the others actually got burnt while they are at the uppermost floor. So, we can have certain strategies, but we never know whether they will fail or no. In this case, there were not enough, secondary escape paths. The only path that they had was blocked during the fire. And this is another, maybe in our buildings that are in Colombo, we will have the scissor stairs, right? The same stairway that is accessible from the same level with two entrances. And if you don't separate these scissor stairs using a fire-resistant barrier, maybe one path can be secured, but if the fire breaks into, if by any chance one exit door breaks and the fire or smoke comes in, the whole scissor stair shaft is blocked. You can't use the other secondary stairwell as well. So, luckily we have certain, we have concrete walls which act as barriers, but in certain other parts of the world, there are specifically designed barriers for these scissor stairs, which are fire rated and up to the standard as well. So some of the mitigative measures that we can use in terms of evacuation, we can have this pressurized lift stairwells or lift shafts where internal pressure does not allow any smoke to reach in, so that you have a safe evacuation path. And we can have refuge floors, because everybody cannot come down at the same time. So certain levels of your building are demarcated as refuge floors. You can wait there until the fire is controlled or firefighters come and rescue you. And we should be mindful about this width of the staircase. So you may remember this scene from Mr. Bean, so where he didn't have enough space. So this could actually happen in case of a fire. No offense to the elderly people, but we have to understand that there are certain, age groups, certain children, and we have to make, either we have to widen our staircases, or we have to place some strategies so that the elderly and the other people have a certain way of not using the staircase and be safe until the fire is controlled. So the point is, actually, there is no uniform solution to all buildings. So there may be certain catered solutions. So that is where this performance-based design comes into play. And thirdly, the firefighters' difficulties. We are a developing country, actually. We don't have this sophisticated instrument. Even though we have these instruments, there are certain limitations. So one, the height and the access. So we have certain limitations with our ladders. And interior firefighting, you need to carry all your equipment inside if in case you need to control the fire. And fatigue and delayed response. So they are also human beings. So if they climb several stairs with all the equipment and the smoke and the heat, they will get fatigued. And there are certain cases that fatigue has killed people as well. And then the smoke management, actually, smoke is the number one fatality. So if you manage the smoke poorly, and if the fire stairs and lift shafts are not, allowing the firefighters to walk in, if they face people who are coming back or coming down from the same stairway, their firefighting efforts can be delayed. And finally, the intense heat and the fire load. So all of this have to be done in a very, dangerous environment. So due to these facts, firefighting is very difficult when it comes to tall buildings. And I can highlight certain examples. We'll take the Grenfell Tower itself. So it started in the 4th floor, but it spread to the upper floors as well. But the ladders could only reach to the 12th floor. Beyond that, they have to, manually go and control it. So they have to ascend to the stairways under intense heat and smoke. And then this example in this building in South Africa. So the fire broke on the 23rd floor. Actually, 3 firefighters died. One fell down from the height, and others succumbs to the exhaustion, the fatigue, and the smoke. So the reason was the internal stairwells. They had no fire separation or any smoke control. So unfortunately, the firefighters had to bear the cost. And then this building fire in Iran. 16 firefighters got killed. And the reason was while they are controlling the fire, actually the building collapsed. So that is also one reason. When you are entering, the firefighters, when they are entering a certain building, they don't know the condition, right? Because it's very uncertain. That is where these fire panels and the control boards that will help them to navigate to the exact location rather than wasting their time on a building which is going to collapse in a moment. So some mitigation measures, actually firefighter lifts dedicated and the command centers at the bottom of your building, maybe refuge floors, pressurized stairwells, compartmentation as I mentioned, and also these firefighting drones. We were talking about new technologies. So rather than the person going upstairs all the way, we have now these commercial firefighting drones that we can use. From the downstairs itself you can control, but up to a certain level only. We can't, total extinguish, but at least control. Then finally, I'm coming back to my last one, the wind and fire. Now, wind-driven fire, the wind can accelerate fire, and also, if by any chance glass or a broken window during a fire, that can have the blowtorch effect, which will, create a flashover suddenly. And actually, this is a study done by Professor Priyan and my colleague Dr. Shanaka. So, computer simulations, they have shown that the wind will, in the graph you can see 50% more area, fire spread area is due to the wind. When there is no wind, it is controlled. With wind, 50% more area of spread. And wind compromises the firefighter safety, as I mentioned earlier, and also the pressure difference and the stack effect. The smoke and the heat goes up, and during a fire through the stairwells and service ducts, and with the wind, actually it confuses things even more. So actually, wind is an invisible force that can transform a contained fire into an uncontrollable inferno, right? Especially at heights, given the wind speed is higher at high elevations. And now talking about a little bit of smoke. So in this study in London from 2015 to 17, more than 1/3 of fatalities was purely due to smoke, right? But others, there is some effect due to smoke as well. And this is a warning sign in one of those buildings. You can, the text is visible, I'm not sure, but it says the number 1 cause of fatalities is the smoke. If you see the smoke, then that means you have to, take precautions and escape. But if the smoke is preventing your escape path, like this, then you can't escape at all. So one thing is smoke is causing you difficulty in breathing and fatalities, and the other one is it is obstructing your evacuation path. So therefore, smoke control in tall buildings is also very important if you are trying to achieve a safe building. And this is another video showing the effect of wind on fire. So you can see actually the other building is not visible, but you can see it right now. So you can see the debris from this particular building goes to the next building, the smoke and the flames, everything goes to the next building, and eventually the next building will catch fire as well. So wind will actually create problems for your own building as well as for the neighboring building as well. So wind is a force that we should not neglect in fire design. So few, mitigations, we can have again compartmentation, fire-resistant doors, self-closing fire doors, and control the smoke. You can have smoke extractions or zone ventilation and pressurized travels. But when I say these things, you will say that, okay, these are nice words and nice things, but can we include everything in our building? Because that is also not possible. These are expensive and these need a lot of design as well. So that is where this performance-based design comes in. Certain buildings, we may not need all of them. Certain buildings, we may need certain things. That depends on your building shape, the characteristic, the amount of fuel load that you have, the people who are occupying that building. So if you try to write a code for everything, the code will be like more than several thousand pages. So you can't write a code catching everything. So that is where the code gives us permission to do performance-based design. So under I will briefly touch on it and finish my presentation in a couple of slides. So under performance-based design, we have a certain performance requirement that we should meet given the type of the building. And then we have a certain performance solution and a deemed to satisfy solution that is given from the code. So following a code is just following some prescriptive guidelines. But if you are going for the performance solution, either you should go with fire test, doing small scale or large scale, or you have to go with fire simulations or with a combination of both, right? Depending on the cost and the time that you can allocate. So this has to be done with the person who is, who has the knowledge on fire engineering, and that is where through Society of Fire Protection Engineering, we are trying to make you more aware, deliver you more short courses, and ultimately our plan is actually to have this in our undergraduate or maybe postgraduate level curriculum someday in Sri Lanka, so that people who are interested can learn this and actually get a professional fire engineering certificate at the end of the day, so that you can be a real fire engineer who do this performance-based modeling. So these are some of the examples. This is a, full-scale facade test, not full-scale actually. This is 2-story height facade test that we did. And we did to see how the two different materials help to spread the fire or control the fire, and also to see the effect of wind. And based on this experiment, then we did the modeling at Moratuwa later on, and then we publish it as well, and to see the effect of wind. So during the test, we can only simulate one scenario, but if you do a validated numerical model, then you can simulate a lot of different scenarios and see how the effect of wind contributes to the growth of fire in the presence of a combustible material. And now these are the events that are from all around the world, and as I mentioned, fingers crossed, I didn't have anything to show from Sri Lanka. So the next big fire, hasn't struck Sri Lanka yet, hopefully, and I hope not as well. So must we wait until a disaster occurs? Yeah, that's the, maybe I was just 4 years at that time. So, yeah. So actually, we may have learned certain things about explosions and terrorists and those things. That of course may have been a result of having our own fire code, at least a certain prescriptive based guideline. But the world has changed. Now we have been moving to combustible material. More and more combustible material are there in our buildings and the exterior. And there are a lot of fires, but in recent past as well, a lot of incidents are there, but not casualties. Maybe thanks to our, fire brigade, or maybe the people who are acting on it. So luckily we don't have fatalities. But like I mentioned, certain events change certain countries and the global aspects or the belief on fire engineering. So my message is, let's not wait for that next big thing to happen. So let's be proactive and do something about it. So the way forward, I will put it in 3 ways. One is the integrated design approach. We have to, the fire engineers' input should come in the early stage of your projects. And I'm glad that the architects, the QAs, all the professionals are here. So consult fire engineer or someone who knows about these things when you are doing your design in the first stage, from the conceptual stage. And go to performance-based solution. Go beyond the code, not just rely on certain guidelines. do a risk assessment, do a fire dynamic simulation, do a evacuation model. Mr. Shiromal, CSEC have done some interesting models as well on certain projects, so to show that the client that this thing is working rather than just relying on certain guidelines. And finally, we have to use resilient materials, like Professor Priyan discussed, resilient systems in the broad picture, not just material testing, but testing the whole system, whether that is in accordance with the fire guidelines. So I will finish off my session with this. So as a summary, during tall buildings, the claddings fire are a growing threat, and evacuation in tall buildings is slow and risky. And the firefighting faces many physical and tactical barriers, logistic barriers, and finally the wing exacerbates this fire and smoke spread. So therefore, we have to have an integrated approach and performance-based design approach involving the fire engineers and all the other professionals from the early stage, using more modeling simulations to prove your design is correct, and also promote these fire resilient materials. So as I mentioned, I will briefly mention about our Society of Fire Protection. So you can follow our LinkedIn page. And of course, in July 31st also, we are having an online session on investigating certain fire incidents. Of course, with the help of my colleague, Dr. Shanaka, who's in Melbourne, working in a fire engineering consulting firm. And he is the one who's connecting all these professionals who brings this knowledge to us. So, students, it is free. For recent graduates, it is 50% off. And for all Sri Lankans, it is 25% off. So, you can follow this QR code and the link. And if you go to the LinkedIn page, we will, actually last year I promised, but definitely I will do this. Have a, short brief on how to take the membership step by step. And we'll put that on our LinkedIn page. So if you are interested in these topics, you can join us. And so I must thank Dr. Shanaka, myself, Dr. Shanaka and Professor Priyan. We initiated this Society of Fire Protection, and with the help of Mr. Shiromal and others, we now move ahead. And my PhDs, not my master's students now who are doing PhDs in Australian universities, and all other collaborators, students, lab staff, and also funding agencies who have supported us so far in this short but journey. It's not time for questions. Maybe questions can come in the afterwards during the cocktail. So thank you very much, and hopefully this was more like an eye-opening session for you to just understand the risk and the things that we have to deal with in case of a fire in tall buildings. And I hope you will take this message positively and act responsibly and incorporate these things in your designs next time. Thank you very much.
Thank you, Dr. Fasindu. Great ending to the forum. We are happy to have you again this year. Bear with us for 10 more minutes. We now present a video from another gold sponsor, IRO Solution, IRO Holdings Private Limited, ensuring confidence and coverage for the future.
In the life cycle of any construction, challenges are inevitable. From the insidious spread of corrosion and the silent threat of structural cracks, to the devastating impact of fire and the persistent damage caused by water, these issues threaten lives, devalue assets, and erode investments. At Aero Solutions, we provide the advanced protection solutions that address these very challenges head-on. With over 15 years of industry leadership in the construction and industrial sectors of Sri Lanka, we are dedicated to safeguarding your assets and ensuring peace of mind. We achieve this by partnering with world-renowned brands like Nullifier, RD Coatings, Firespray, VIP Coatings, and Excalibur, bringing you the highest quality products and unparalleled expertise. Our commitment is to deliver smart protection that meets the most stringent international standards for every project. Corrosion protection with RD Coating. For superior corrosion protection, Aero Solutions proudly partners with RD Coatings, a trusted brand in water-based technology. We are the sole distributor and approved applicator for RD Coatings products in Sri Lanka. RD Coatings offers cutting-edge solutions for various environments. RD Monoguard, a next-generation water-based anti-corrosion coating that provides long-term protection, high UV resistance, fast drying, and surface tolerance. It's a single-component solution capable of protecting steel for over 15 years in C5 marine or industrial environments. RD Elastometal, a high-performance elastomeric coating with superior anti-corrosion and waterproofing properties. It adheres perfectly to various substrates, offering high elasticity and durability, even in the most severe weather conditions. RD coating systems are designed for minimum 15-year durability, tailored for C3, C4, and C5 environments, ensuring long-lasting protection for your steel assets. Passive and structural fire protection with nullifier. At the heart of our fire safety solutions are passive fire protection and structural fire protection, a critical element in compartmentation and preventing the spread of fire. We are the sole distributor and approved applicator for Nullifier UK products in Sri Lanka, a globally recognized leader in intumescent fireproofing and fire stops. For sealing joints, gaps, and service penetrations, we utilize FS 702 waterborne intumescent acrylic sealant, FS 709 intumescent mastic, and FF 197 fire-rated PU construction foam, all designed for superior fire resistance and sealing. To seal combustible pipes passing through walls and floors, we offer FP 170 intumescent pipe collars and FP 300 intumescent pipe wrap, providing robust fire-stopping capabilities for up to 240 minutes. Our intumescent coatings are meticulously selected based on ISO 12944 and ETAG standards, ensuring optimal performance across various corrosive environments. FB 750 coated batt, a mineral fiber board with an ablative elastomeric coating, offering up to 240 minutes of fire resistance for various penetrations. For structural steel, we offer advanced intumescent coatings like SC 801, SC 902, and SC 601. These thin film coatings expand in a fire to provide insulation, protecting steel structures for up to 120 minutes. SC 902 in particular is a fast-track on-site, low VOC solution. Duct fireproofing with fire spray. Ensuring safety and ventilation systems is paramount, and for duct fireproofing, Aero Solutions collaborates with Firespray Flamebar UK, experts in passive fire protection systems for ductwork. Firespray solutions include Flamebar BW11, a specially formulated water-based ablative coating that provides enhanced performance in fire-rated ductwork systems, contributing to containment of ventilation smoke, pressurization, and kitchen extract ductwork. Flamebar intumescent acrylic sealant, a key component for fire-rated ductwork systems, sealing joints and penetrations, offering 4-hour integrity and insulation rating. Flamebar fire retardant gasket, a highly flexible PVC nitrile rubber foam tape designed to be squeezed between duct flanges, ensuring a high-quality seal and preventing the ingress of grease while providing a crucial fire barrier. These systems are manufactured and supplied worldwide, meeting stringent fire safety regulations. Beyond fire protection and corrosion control, Aero Solutions extends its expertise through partnerships with VIP Coatings for polyurea and polyaspartic coating technologies for waterproofing, roofing, and industrial flooring, and Excalibur USA for construction chemical products, including waterproofing, concrete repair, grouts, and expansion joint systems. These strategic alliances allow us to offer a diverse range of high-performance solutions for various construction needs. We are committed to excellence in every endeavor. For For smart protection and a safer future, contact Aero Solutions today.
We now present the videos from our esteemed silver sponsors, Criso Lanka Private Limited, Maga Engineering, Worth Lanka Private Limited, and Emerita.
Tomorrow, how will we inhabit our cities when 70% of us live in them? Faced with the challenges of a changing planet, will they be resilient? The answer lies in the materials that shape our world. The buildings we live and work in, the bridges we cross, the tunnels we pass through, and the roads we travel, all need to be built to withstand the complexities of our times. At Criso, we partner with you to turn complex challenges into compelling answers. We unlock the power of chemistry to develop the future of cement and concrete materials, aligning with your priorities of decarbonization and efficiency. Driving new levers of performance with chemical solutions tailor-made for your specific needs, inventing them if necessary. In a world of declining resources and rising transport costs, we foster the circular economy and help you transform local materials into added value. As cities grow vertically and your projects take on new dimensions, we enable you to build without limits. We explore the limitless possibilities of digital technology and AI through the entire value chain, working alongside you to push the boundaries of construction. We build bridges between your projects, our innovation, and our talented teams. Together, we're crafting a new world. A world where challenges become solutions, and complexity is transformed into opportunity. Criso, pioneering the future of construction now.
Welcome to the terrace apartments of Emerita Kelaniya, the very first exclusive boutique apartment in Sri Lanka. It's like living in a forest canopy, elevated above the city. Here, nature isn't just outside your window, a living, breathing connection to nature, from your bedroom to your living room. Your own private sky garden, with fully grown trees hand-picked by you. A living experience like dwelling in a mountain cave wrapped with trees. Step inside. Every apartment is fully furnished, designed with style and intention. Each room opens to a private balcony garden, blending indoors and outdoors. The bathrooms, spacious, spa-inspired. Everything thoughtfully chosen to feel calm, clean, and elevated. At Emerita, every detail is curated for a life like living in a boutique hotel. Enjoy an unlimited all-day buffet by the Fab. Come home to a spotless apartment, cleaned daily by Abens Environmental Services. A wellness zone, steam room, sauna, gym, hot and cold therapy pool, and a tree-lined jogging path. A clubhouse, a restored Art Deco mansion, offers a gaming arena, mini cinema, and a curated library. A world-class lifestyle delivered through our strategic partners, Abens Environmental Services, the Fab, and Hammers Hospitals. Just 16 minutes to Goalface when the Port Access elevated highway opens. And only 35 uniquely designed homes. Only a few terrace apartments remain. This is your moment. Emerita Kalania, the design of life you live.
We are Marga Engineering, Sri Lanka's largest and most trusted construction company. And our story is one of ingenuity, excellence, and resolve. Over the last 3 decades, our footprint has etched across more than 500 multidisciplinary projects. 35 years ago, Mr. M.G. Kularatna founded Marga Engineering with the vision to become a model construction company in the region. Spurred by its vibrant and talented nucleus, Marga seized the opportunities to work alongside some of the world's leading construction companies, instilling within a quality-centered focus that became its trademark. From inception, we have strived to end the ethos of sustainable development across the organization. We are the first privately owned company in Sri Lanka to publish under the Global Reporting Initiative. The trust we have earned from our stakeholders have manifested through our platinum rating in Sri Lanka's Corporate Accountability Index and our environmental stewardship through the first Green Award in the public and private sector. As Asia becomes the fastest growing region in global construction and our breadth of experience and talent opens new opportunities around us, our vision has remained as unwavering as ever: to build lasting social infrastructure and to change the landscapes around us for the better. Marga, changing landscapes, changing lives.
To formally close the proceedings, please welcome Mr. Yasas to deliver the vote of thanks.
Good evening, ladies and gentlemen. As we are about to close this distinguished assembly, it's my honor and pleasure to be here and to deliver a vote of thanks on behalf of the organizing committee of CTBUH Colombo Forum 2025. First and foremost, we extend our deepest gratitude to our distinguished keynote speakers who joined us all the way from Australia, Professor Priyan Mendes, Mr. Edian Penacola, and Dr. Pasnu Veerasinghe from University of Moratu. We are equally honored by the presence of our chief guest, Mr. Ravi Nisanka, whose support and encouragement were invaluable. And our guest of honor, Engineer Graniyar Jayalat, Architect Dulmendi Mel, Professor Emeritus Ranjit Disanayaka, Architect Jayanta Pereira, Engineer KLS Sahabandu, and Engineer R.M. Ananda Senarath, QS Indunil Seniviratna, Engineer Mrs. T.J. Jayasundra, Dr. Rohan Karunaratna. Thank you for gracing this occasion and enriching it with your wisdom and presence. A heartfelt thank you goes to our gold sponsors, Tudave Engineering Services Private Limited, Aero Solutions, Aero Holdings Private Limited, Langwa Sanstha Cement Corporation Private Limited, and IIRM Lanka Insurance Brokers Private Limited. Your generous support made this event possible. To our silver sponsors, Criso Saint Gobain, Marga Engineering Private Limited, Emerita, and Worth Lanka Private Limited. We thank you sincerely for your valuable contribution. To the participants of this conference, engineers, architects, developers, academics, students, and industry professionals, thank you for your active engagement and for bringing vibrant energy and insight for every session. A special thank you to BMICH for providing us with the venue and to Mount Lamania Hotel for the food and hospitality. A special thanks also goes to our print media partner, Daily FT, for their support in giving visibility to this forum and helping us reach a wider audience. Finally, to the organizing committee of CTBUH Colombo Forum 2025, your dedication, effort, and teamwork have made this event a resounding success. Thank you, and have a pleasant evening.
I now invite Engineer Shiromal and Professor Priyan on stage to hand over the tokens of appreciation to our external keynote speakers. Mr. Adrian and Dr. Pasindu, can we have you on stage? Thank you, Mr. Adrian. Dr. Pasindu. I now invite the chief guest and guests of honor on stage to accept the tokens of appreciation, Mr. Ravi Nisanka, Engineer Granny Jayalath, Architect Domini Demel, Professor Ranjit Disanayaka, Dr. Rohan Karunaratna, Architect Jayanta Pereira, Engineer KLS Sahabandhu, Engineer TJ Jayasundara, Engineer RM Anand Senarat, and QS Indranil Senaviratna. Thank you, Professor and Mr. Shiroma. That concludes the formal agenda. You are warmly invited to join us for refreshments and networking as we continue to build connections and ideas for a vertical future. Thank you and enjoy the rest of your night.